Hello students, can you all hear me? So please type in the chat box, can you all see the screen and can you hear me clearly? Yeah, so please type in the chat box students. Can you all see the screen clearly and can you all hear me? Please type in the chat box, be quick. So please type in the chat box, can you all hear me? And can you all see the screen clearly? Yes? So please respond a bit. Yes, so fine. So basically in this session we'll cover the detailed solutions. So I thought of giving just the answer key, but yeah, we have time. So just we can get the detailed solutions of both the things, XCA engineering mathematics and also XCB fluid mechanics. Clear? So we'll get to know of all these detailed solutions of the questions that came in GATE 2021 XE and we'll discuss this. Okay, so let's start with mathematics because 15 marks straight away came from engineering mathematics. So let us discuss these questions of engineering mathematics first. So let us straight away go for the first question. So this is the first question that is with us. So anyhow, I am going to provide the detailed solution for you, and for the time's sake, if someone got answer as 0.375 then that's that, and please tell me how many of you got this answer as 0.375. So how many of you have got this answer as 0.375? So please respond. Be quick. Yeah, so please be quick. How many of you got this answer as 0.375? I would like to know from you. Please do respond. Okay, so anyhow, let us see the question. So a person who speaks the truth 3 out of 4 times, means if you take this as an event, the probability of speaking truth is how much? This is given as 3 by 4, means out of 4 times he speaks truth only 3 times, correct? So he throws a fair dice with 6 faces and informs that the outcome is 5. Look, what is the probability of getting 5? What is the probability of getting 5? This is nothing but 1 by 6 in a fair die case, correct? In a fair dice case, the probability of getting 5 is 1 by 6. So if you want to know the probability of reporting 5, probability of this person reporting 5, then there are 2 ways in which he can report. One thing, it can be actually 5 and then he could tell the truth, or else didn't get 5 and he could have told false, correct? So in that case, let us suppose he told the truth, or else let us suppose there is actually a 5 and the probability of getting a 5 is 1 by 6 into 3 by 4 is the probability of speaking truth in that case. Or there is also one more possibility that there is no 5 on the dais, means the probability of not getting 5 is 5 by 6 and that time he have lied. In both these cases, the outcome from his mouth that he reports a 5 has occurred, correct? So this is what it happens. So total probability of reporting 5 is equal to 3 into 1 by 24 plus 5 into 1 by 24. This is what we have for the total probability that this guy reports a 5. There are 2 possibilities. There can be an actual 5 and he can report truth, or else the 5 didn't occur but he lied. In both the cases, the outcome from his mouth is that he tells us that a 5 has appeared. Now out of these 2 cases, means when you know that he reported 5, what is the probability that it is an actual 5? It is actually a 5. This is the thing that was asking. Now see here. This is the total probability which you have 3 into 1 divided by 24 plus 5 into 1 divided by 24. This is what you have, and of course out of these 2 terms, this is the term, or this 3 into 1 by 24 is the case of actually getting a 5 in a dice. So we'll write that on the top. So this is a simple application of Bayes' theorem and you could easily sense this answer. Okay, and you could clearly see there are 2 possibilities for the event of reporting 5 to happen, and out of these 2 possibilities, this 3 into 1 by 24 is the actual possibility of getting a 5. So if you perform a bit of calculations here, so 3 by 8 is the answer, and this could, I would like to show you with the help of a virtual calculator here as well. So no issue. Let us take the help of a virtual calculator. Let me quickly show you the values also. So GATE calculator, then there's a scientific calculator first. So this is the same calculator that gets displayed in your exam. So 3 by 8 could give you 0.375, and this is what they asked you, round off to exact 3 decimals and you could get the answer to exact 3 decimals, no issue. Okay, so this is how the answer for this question is 0.375. Clear? Is that clear to all of you? Are you all having any doubts at any point? Basically, this is a simple application of Bayes' theorem. When there are multiple possibilities for an event to happen, then what is the probability that this event has happened because of this particular possibility? Correct? So 0.375 is the correct answer for that. Is that clear to all of you? Is that okay? Can we go for the next question? How many of you has written this correct? So please tell me how many of you have written this question correctly in exam. How many of you have written this question correctly in exam XC? So please do respond. If you do respond, then we'll go for the next question quickly. So how many of you got 0.375? At least one. So please do respond, because this could be an interactive session. It could be helpful only if this session could be more interactive. So please do respond from your side. Next, let's go for the next question quickly. Then this is the next question. Let f of x be a non-negative continuous function of real variable x if the area under the curve y is equal to f of x from x is equal to 0 to x is equal to a is given by that particular expression, like a square by 2 plus a by 2 sin a plus pi by 2 cos a minus pi by 2. Then the value of f of pi by 2 is dash. And they have asked you to round off to one decimal place. So now, please tell me, did any of you get 0.5 in exam? How many of you tried this question sincerely in exam but didn't get the answer? How many of you got the answer as 0.5 in exam? So please do respond. Please respond. Look, this is a very easy question, because this question came for 1 mark as far as I remember. But this question is a really easy question. The only thing that you need to do is a little adjustment. Look, first of all, let us see the geometrical meaning of the things. If f of x be a non-negative continuous function, means, look, if this is your x and if this is your f of x, then non-negative function means the f of x values are positive, correct? So this is y is equal to f of x, correct? So this is what we have, and this is the area, which means this area is mathematically equal to integral 0 to a f of x dx. Yes or no? If this is, okay, let us write from here itself. So this area, if this is x is equal to a, then integral 0 to a f of x dx is given by this answer. I guess the answer in exam. Okay, what was your guess in the exam? It's exactly 0.5. I'll show you how it is. Look, integral 0 to a f of x dx. This is what the area that is given, and that area is equal to a square by 2 plus a by 2 sin a minus, or else plus pi by 2 cos a minus pi by 2. This is what you have with you, correct? Now, the only thing, can I write this expression as x square by 2 plus x by 2 sin x plus pi by 2 cos x within the limits 0 to a? Can I write this? Please respond. Can I write this? Can I write this value which is given here as this function with the lower limit as 0 and upper limit as a for the substitution? Can we do this? If we can do this, then see carefully. When you substitute a, you have a square by 2 plus a by 2 into sin a plus pi by 2 into cos a minus. When you substitute the lower limit, these two terms will go to 0 and cos 0 is 1. So you have a pi by 2, and that's exactly pi by 2 in the lower limit. Did you all understand how I have deducted this term or this step from this particular given data? Is that understandable to all of you? Yes or no? So please respond. Did you all understand how this expression is same as this? X square by 2 plus x by 2 into sin x plus pi by 2 cos x within the limit 0 to a? Yes or no? So please do respond, guys. I'm awaiting your responses. Did you all understand this? And do please like the video if you're liking the way that we are solving the questions. Okay, anyhow, let's go for the things. Now, if integral 0 to a f of x dx, if this is given as x square by 2 plus x by 2 into sin x plus pi by 2 cos x within the limits 0 to a. Now, can I tell one thing, that integration of f of x is nothing but this value? Let us write this. So, integration of f of x dx is nothing but x square by 2 plus x by 2 sin x plus pi by 2 cos x. This is what we can write. This is what we can write, correct? This is what we can write. Now, see carefully. This integration of this is something like this. Now, if you want f of x, what can you do? You can just differentiate the things. If you differentiate, then f of x is equal to differentiation of x square by 2 is x plus differentiation of this is 1 by 2 times x into cos x plus sin x, and differentiation of this particular term here is minus pi by 2 sin x. This is what you have. And in exam, they are asking you for f of pi by 2 value. Correct? Now, see carefully. If you put pi by 2 here, plus 1 by 2 into cos 90 will be 0. So this value is 0 plus sin 90 is 1 minus pi by 2 into sin 90 is again 1. So you can see clearly this pi by 2 and minus pi by 2 gets cancelled, and you have left with 1 by 2, which is 0.5. That's it. Clear? Of course, it's just 2-3 steps, but of course thinking and readjusting the term here, this step is the crucial heart of the question. Okay, so see here, this part, writing this from this particular step is the main part. Did you all understand how this answer is 0.5, and how many of you have written this in exam? So please do respond. How many of you have solved this question exactly to 0.5? See, it's just only 2-3 steps. nothing more than that. Clear? Are you all clear so far? Maths is the toughest among all. Oh, is it? Okay. Anyhow, let us try to solve the questions and let us see how tough it is. Okay. Next, let us go for the next question. So this is the next question that is with us. So let the transformation y of x is equal to e power x into v of x. So v of x is some function again. So e power x into v of x reduces the ordinary differential equation. So we have one ordinary differential equation here. So x into d square y by dx square plus 2 times of 1 minus x into dy by dx plus x minus 2 times of y. This is equal to 0. Correct? This is equal to 0. Now x is positive, of course. Now they are telling you that instead of y, if you substitute this function, e power x into v of x, then this particular ordinary differential equation gets converted to or reduced to this particular form. Then they are asking you what's the arithmetic mean of alpha, beta and gamma. Correct? Now you need d square y by dx square and also dy by dx to substitute that function in this equation. Correct? So let us calculate that. So y dash of x is equal to, if you differentiate this function with respect to x, e power x into dv by dx. Okay, let us write v dash of x for the time being. Okay, next v of x into e power x, which means you can simplify this to e power x times of v dash of x plus v of x. This is y dash of x. Next, if you want to have this d square y by dx square, you can still differentiate this. So once again, if you differentiate this, we have this e power x is the first function. So if you write the differentiation of this function, v double dash x plus v dash of x plus again this function into this e power x, so which is v dash of x into or plus v of x into this total term multiplied with e power x. So if you take an e power x common, you will be having y double dash of x is equal to e power x. If you take common, then v double dash of x plus 2v dash of x plus v of x. This is what you have. Clear? So this is the expression that you have for y dash of x. Clearly, this is the expression that you have for y dash of x, and this is the expression that you have for y double dash of x. So let us substitute these two expressions in this particular equation. Okay, so if you substitute x into d square y by dx square, which is e power x into v double dash of x plus 2 times of v dash of x plus v of x. This is what we have, plus 2 times of 1 minus x into dy by dx, which is e power x into, again you have v dash of x plus v of x plus x minus 2 into y. And what is y? We can substitute y as e power x into v of x. This total summation is equal to 0. Okay. Now one thing that you can do, you can cancel all this e power x from all the terms, and if you try to frame the equation, you will be ending up with x into d square v by dx square. Just simplification. I told you till this point, so you can just write the things simply. That's it. Again, you will get 2 times of dv by dx plus v. That's what we'll be having, and this is 0 is equal to 0. This is what you'll be having finally, and this is the differential equation that you'll be ending up with if you solve this equation a bit. And it's just differentiating a function 2 times and substituting properly. So you can feel that the value of alpha will be 1. You'll feel that the value of beta will be 1 finally, and you'll feel that the value of gamma is 0. So the average of all these things, alpha plus beta plus gamma by 3, arithmetic mean, which is 1 plus 1 plus 0 by 3, which you will be getting 2 by 3, and you know very much that the value of 2 by 3 is 0.667 if you round up to 3 decimal places. Correct? Can you all understand this? This is a very simple question actually. Just with the basic knowledge of differentiation, you can try to attain the solution of this. Is that clear to all of you? Are you all clear so far? It's very simple thing. Just differentiate the given function twice and then substitute in this equation and make bit of simplifications. Okay, that's it. You will get 2 by 3. Clear? How many of you wrote 0.667 in your exam? So please do respond. How many of you have written 0.666 in your 0.667 in your exam? Or it's okay, 0.666. How many of you have done that? Okay, anyhow, let's go for the next question. So, yeah, this is the next question. So, let us try to read the question. The numerical approximation of the value of the integral. So, they have given you some integral 0 to 4. Yeah, you wrote it, Shyam here. Good. So, see here, this integral 2 power alpha x dx, this is given as 9. Okay. Then the value of the real constant alpha. So, what is the value of the real constant? 0.67 is correct. Yeah, it can be correct. No issue, Sai Teja. So, see here, integral 0 to 4 2 power alpha x dx is equal to 9. And they have evaluated this integral using this trapezoidal rule with 2 subintervals. This point has to be made a note of. So they have evaluated this integral using trapezoidal rule, but of course only with two subintegrals, or sorry, two subintervals. Then definitely if you have this starting value as 0 and this is 4, then step size is equal to 2, because to have only two subintervals. Then that's pretty much clear. If you form the table that you generally form for the trapezoidal rule, for the value of x, you have 0, 2 and 4. And similarly for the value of f of x, you have 1, 2 power x, it's 2 power alpha x, so 2 power 2 alpha, and this is 2 power 4 alpha. This is the table that we have, correct? So this is what we have, and now if you apply the trapezoidal rule for this, 9 is equal to, because the value evaluated using trapezoidal rule is 9, so 9 is equal to, h step size is 2, so 2 by 2 into first value plus last value, which is 1 plus 2 power 4 alpha plus twice of the remaining values, which is 2 power 2 alpha. So this is what the expression we have, correct? So if you solve this equation a bit, you will get alpha is equal to 0.5. Anyhow, I will show you how to solve. So 2 gets cancelled and 9 is equal to, look, if you look a bit carefully, can we write this 2 power 4 alpha which is here as 2 power 2 alpha whole square, because you know very much a power m whole power n is nothing but a power m times of n. So definitely if you have this 2 power 4 alpha, that you can write it as 2 power 2 alpha whole square. Now if you take this 2 power 2 alpha as a, then you have a square plus 2ab plus b square form. So this equation on the right, or this expression on the right, it's nothing but 2 power 2 alpha plus 1 whole square. This is what you have. And now you can solve this equation for getting alpha. Let us solve. So this implies 2 power 2 alpha plus 1 is equal to 3. So this implies 2 power 2 alpha is equal to 2, and this is 1. So when bases are equal, exponents are also equal. So 2 alpha is equal to 1 and alpha is equal to 0.5. That's it. Okay, clear? This is a very simple equation to solve, and of course you need to think one thing, that this expression is nothing but 2 power 2 alpha plus 1 whole square. Okay, so if you have that, then things are fine. Clear? Shall we go for the next question? Is that clear to all of you till here? Are you all clear till here? Yes or no? So please respond. Are you all clear till here? Okay, please do respond, guys. No, it's exactly giving 0.5, so I feel that they may not give range for this question. Okay, anyhow, let's go to the next question. Yeah, this is one question. Let S is equal to set of AX such that A is this matrix and X is a 2 by 1 matrix. So this is of order 3 by 2 and this is of order 2 by 1. So basically if you multiply this AX, let us multiply that. So A times of X is equal to 2 minus 4, 1, 1, 1 minus 1. This is what we have, and of course this multiplied with x1 and x2. Okay, so if you do this multiplication, then this is equal to 2x1 minus 4x2. Next x1 plus x2. Next x1 minus x2. So any element in this set S will be of this form, correct? Because this set S contains the elements A into X, but of course this is A and this is X. So any element that if it lies in S, then definitely this is of this form, and it's given clearly this minus 1 alpha 1 also belongs to S, which means if minus 1 alpha 1 is belonging to this S, then definitely this minus 1 alpha 1 should be similar to something like this. So if you equate the terms correspondingly, x1 minus x2 is equal to 1 and 2x1 minus 4x2 is equal to minus 1. This is what you have, and of course if you multiply this equation with 4, for example, 4x1 minus 4x2 is equal to 4, and if you subtract few things, then this gets cancelled, and 4 minus 2 is 2x1, which is equal to 5. So x1 is equal to 5 by 2. This is what you have. Okay, so if x1 is equal to 5 by 2, then x2 is equal to 3 by 2, because 5 by 2 minus 3 by 2 is nothing but 1. So x2 is equal to 3 by 2. So they are asking you for the value of alpha. So what is basically this alpha? This is nothing but, oh, I'm sorry. Okay, so what is this alpha? Basically this alpha is nothing but x1 plus x2. So x1 is here and x2 is here. So if you add up these two things, x1 plus x2 is nothing but, you have a common 2 as LCM. So 5 plus 3 could give you 8 and this could give you 4. So 4 is the value of alpha, which is here, and that's you have exactly in this option. Clear? Did you all understand how this is for? And if you're liking the session, please do like the video, share it to your other friends, so that whoever is waiting for the key of XC, Engineering Mathematics and Fluid Mechanics, they'll get the key for that. Okay, and also the detailed solutions, how the answers are these. Clear? Are you all clear till this point? Yes or no? So please do respond, friends. Okay, so shall we go for the next question? Are you all clear how alpha is 4? Yes or no? Clear? To be frank, we can't remember the marks per individual question unless the question papers are out, because this year, as you know, it's not like last year. All the 1 mark and 2 mark questions were jumbled and they were mixed up. Okay, so until the moment we get the final question papers, we don't know which question is for 1 mark or which question was asked for 2 marks. Okay, but anyhow, knowing the solution is a bit fine. Cool. Let's go for the next question. Okay, there is one question. How many of you have solved this question? Before I start solving this question, please tell me how many of you have solved this question in exam, because this is one very nice question. So please tell me how many of you have solved this question in your exam? Because I will be telling you, if I straight away solve the question, you feel like this question was very easy and that question was very easy. But if you try to, let us have some fruitful discussion with the people who have given the exam and who have attempted all these questions. Anyhow, let us go to this question. So let C1 be the line segment from 0, 1 to 4 by 5, 3 by 5. So if you see, let us try to plot a xy coordinate axis. So 0 and y. Okay, so let us suppose this point is 0, 1, and it's obvious your 4 by 5, 3 by 5 like somewhere here, correct? Because 4 by 5 is 0.8 and 3 by 5 is somewhere here. So this is what we have. So see carefully. This is a line segment which is connecting these 2 points. Let us suppose A and B, and they are asking you for alpha square plus beta square. Okay, so where is this question? Rest of the part. Okay, so finally what they are asking you for is this alpha square plus beta square, where this beta is integral over C2 2x by y I bar plus 1 minus x square by y square j bar, and of course into d bar. And of course they have given you what is this C2. C2 is the arc of the circle x square plus y square is equal to 1. Then let us see here. So from 0 to 1 the arc of the circle is something like this, and from 0 to 1 the line segment is something like this. Now alpha is the evaluation of this integral along this line, black line, and beta is the evaluation of this integral along this path, which is a part of circle, or it's a circular arc. Correct? This is what we have seen. Now please tell me one thing. For solving this question, we have one very nice approach. Can you all recollect that this f bar means if you have any integration, like if you have any integration along any path, cyclic integral, or maybe a normal integral for the time being, from 2 points A to B, f bar dot dr bar. If you want to evaluate this integral, and if this f bar is irrotational, then do you know? Look, I'll tell you. If this is the line integral between 2 points, then if this f bar is irrotational, then can you understand that this integration is independent of the path connecting these 2 points? Look, please don't do that in the chat box. It's okay. Let's have some discussions. That's it. Okay. So please see clearly. So integral a to b f bar dot dr bar, if this is the line integral and if this f bar is irrotational, then can you all understand, or can you all recollect the point that this integral is independent of the path AB? Yes or no? Can you all understand this? Or can you all recollect this point? If this f bar is irrotational, then this integration is independent of the path connecting A and B. Yes? Fine. Look, see carefully then. Which means if you evaluate this integral, which is given like this, along C2 or C1, the value remains same. If this vector f bar is equal to 2x by y I bar plus 1 minus x square by y square j bar. If this is happening, then definitely, if this is irrotational, then both these integrations alpha and beta have to be same. So let us find whether, first of all, this integral means this vector point function is rotational or irrotational. Let us do that. So f bar is equal to 2x by y I bar plus 1 minus x square by y square j bar. This is what we have. Okay? Now, if you look, for applying Green's theorem, you should have a continuous closed path, but of course here the path is not continuously closed. Why? I will tell you. Look carefully. Because both it's not forming a cycle. Both are intended towards the same direction. Okay. So first thing, you can't apply Green's theorem to get this value of alpha square plus beta square. Is that clear? Because you are not closing the loop. Both the curves, they are going from 0 to 1. I mean 0 comma 1 to 4 by 5 comma 3 by 5. This is also going from 0 comma 1 to 4 by 5 comma 3 by 5. So they are not forming a closed loop. So you can't apply Green's theorem. Is that clear? Because both the points are going to the same direction. So you can't apply Green's theorem. Is that clear to all of you? First of all, it's not 4 by 5 comma 3 by 5 to 0 comma 1. It's again 0 comma 1 to 4 by 5 comma 3 by 5. So these two are in the same direction. Okay. So you can't apply Green's theorem because this is not a closed path. Clear? Now let us check the rotationality of this vector point function. So if you check the rotationality of this I, j bar and k bar, so dou by dou x, dou by dou y, dou by dou z, and 2x by y, 1 minus x square by y square, and 0. This is what we have. Correct? So now let us calculate the value. I bar times of, look, dou by of this is 0 minus dou by dou z of this function is also 0. So we don't have any I bar component. Minus j bar of 0 minus 0. Again it's 0 plus k bar times of, look, dou by dou x of this, which is, if you differentiate this expression partially with respect to x, minus 2x by y square is what we will be having. Minus dou by dou y of this term, which is again dou by dou y of this term will again give you minus 2x divided by y square. And you can clearly see they get cancelled off because minus 2x plus 2x. So this is 0 bar. So which means this vector point function is irrotational, which means one thing that you can check, if you go by path C1 or if you go by path C2, both are same. That means you can do one thing. This alpha square plus beta square value, you can write this as 2 times of beta square. Correct? If alpha and beta are same, means if the integral value is same, then alpha square plus beta square will give you 2 times of beta square. This you need to understand. Now what is beta? Integral over path C, 2x by y dx plus 1 minus x square by y square dy, and the C is along the path x square plus y square is equal to 1. So since you know complete segment of this arc lies in the first quadrant, so you can write y is equal to square root of 1 minus x square, which means your dy is equal to 1 by 2 root of 1 minus x square into minus 2x into dx. And you can cancel this 2 maybe, and this can be written as minus x by root of 1 minus x square dx. Okay, so this is what we have. Let us shorten the scale a bit. Okay, so this is what we have. Now let us substitute all these things here. So beta is equal to integral over c 2x by y. Y is nothing but root of 1 minus x square dx plus 1 minus x square by y square. 1 minus x square by, and along this path y square is nothing but 1 minus x square into dy. Dy is nothing but minus x by root of 1 minus x square dx. Okay, look, majority of the problem, it belongs on your understanding that if this is irrotational, if you check for irrotationality of this function, then alpha and beta will be same. This is what the key point of this question. Okay, so once you know the key point, then things are very much easy. You can cancel this. So 2x minus x, what we have finally, integration x by root of 1 minus x square dx. And of course, you know x is running from 0 to 4 by 5. This is what you have. So if you perform the integration, you will end up with 0.32. This is a simple single variable integration. So you can integrate the things clearly and you'll get 0.32 if you calculate. Okay, so please try this when you find some time, because you know this integration can be done very simply, because if you make a little adjustment of minus 2x and minus 1 by 2 here, then this minus 2x is nothing but the differentiation of this 1 minus x square, which is inside the square root. Okay, so just you can apply the integration and you can solve. 0.32 would be the answer for this question. Okay, fine, clear? 0.32 is the answer. It's not exactly of this integral. So let me write few other things here. Look, let us try to evaluate this integration. So minus 2 if you write, and minus 1 by, okay, something happened. Just a second guys. Yeah, better. So if you write this minus 1 by 2, so this is minus 1 by 2 into 2 times of root 1 minus x square within the limit 0 to 4 by 5. So you can cancel this 2 and minus of, when you take this is 3 by 5 minus 1. So finally you will be having minus of 2 by 5 actually, correct? Minus of 2 by 5. This is what you will be having, and finally you can calculate the values. Clear? Because space is done, so I am just leaving this integration for you. So you can perform this integration. Okay. So this will be minus 2 by 25. So alpha is or beta is minus 2 by 25. So beta square will be 4 by 25. But alpha square plus beta square is nothing but 2 times of beta square. So 8 by 25 is what you'll get. And you can calculate the value of 8 by 25 easily. 8 by 25 is nothing but 0.32, which you can see here. Okay. So that's how the answer will be 0.32 for this. Okay. So anyhow, at this point, you would like to know what are the answers. So 0.32 is the correct answer for this. Clear? So let's go for the next question quickly, because this question is the only question that took some bit time, and actually for explanation it takes time, but of course if you understand that for this irrotationality case this alpha and beta both are same, then this question is a matter of 3 minutes hardly. Next, let us try to solve this. Let's see with the boundary of the region R such that 0 less than or equal to x less than or equal to pi. So let us try to plot the things. 0 x y. Okay, so this is what we have, and let us try to plot 0 less than or equal to x less than or equal to pi. So x is equal to 0 is nothing but this y axis, and x is equal to pi is something here. Next, y is equal to 0 is something this x axis, and y less than or equal to sin x. The graph of sin x looks something like this. So definitely this is the region that we are talking about. So this is the region which is bounded by all these curves. So this is the closed region, and they are telling you that this region is R. Okay, so this is the region that is bounded by all these 4 curves. Next, let us get back to the point in the xy plane, and alpha be the area of the region R. Okay, so this area region is nothing but alpha. Fine. If C traverses once in the counterclockwise sense, okay, so this C is getting in the counterclockwise sense, then the value of the line integral, cyclic integral over C 2y dx plus 5x dy. 2y dx plus 5x dy. Here, now you can see one thing, this path is a closed path now, because you can see clearly this total region is bounded by these functions which are here. Okay, so in this case you can apply Gain's theorem definitely, because the path is closed. So you can apply the Gain's theorem. This is nothing but integral over the region R. If this is your closed path C, and if this closed path C is bounding a region R, then definitely you can write this integral over C is nothing but dou n by dou x, which is dou by dou x of 5x minus dou m by dou y, which is this 2y dx dy. So this is nothing but integral over the region R. This is 5 minus 2, so 3 times dx dy. So if you take this 3 out, that means 3 times of integral over the region R dx dy, and you know very much this is nothing but the area of the region bounded by this. So this is nothing but which is given as alpha. So definitely this is 3 times of alpha. So which means you can get this B as the correct answer in this case. Yes, Kavanya, you are correct. And I'm happy that many of you are telling the answers actually. Look, as long as your fundamentals are very strong, you feel things easy. Okay. Okay, next. Shall we go for the next question? Shall we go for the next question? Is that clear to all of you? Shall we go for the next question? See, let's go. So this is one thing we have. Let u of x comma y is equal to some function be such that both u and v satisfies the Laplace equation in a domain sigma or omega of the xy plane. Then which of the following is true in this plane? So see, good Aditi Patil. Yeah, very good. So see here, let us try to solve this question. So you have u of x comma y is equal to x square minus y square into v of x comma y. So this is what we have, correct? So be such that both u and v satisfy the Laplace equation. What's the meaning of both u and v satisfies the Laplace equation? Look, we'll be telling you. If u satisfies Laplace equation, then dou square u by dou x square plus dou square u by dou y square is equal to 0, and this also should be equal to dou square u by or dou square v by dou x square plus dou square v by dou y square, because it's clearly given both u and v satisfy the Laplace equation, and you know very much this is the Laplace equation. So u and v should satisfy the Laplacian equation. Now they are asking you for which one of the following options is true. So see carefully. If u of x comma y is equal to x square minus y square into v of x comma y, then what could be your ux? Means the partial derivative of u with respect to x square minus y square into vx plus v times of partial derivative of this, which is 2x. Okay, this is what we have. And of course, uxx, if you differentiate this partially one more time, then you could get x square minus y square into v xx plus vx into 2x. Again, partial derivative of this thing, which is v times of 2 plus 2x times of vx. This is what we have. Correct? Similarly, if you write what is partial derivative of y, uy, if you write, then uy is nothing but x square minus y square into vy plus v times of minus 2y. Okay, now if you differentiate this one more time with respect to y partially, I am writing here because of cos. So see here, if you differentiate this partially with respect to y, again you have x square minus y square into vyy plus vy into minus 2y. This is what you have, plus again that term will give you v of minus 2 plus minus 2y of vy. This is what you will be having. Correct? So let us add these two equations. If you attempt adding these two equations, look, uxx plus uyy will be 0 because this u is satisfying the Laplace equation. Correct? Similarly, if you take this x square minus y square common, you will be getting vxx plus vyy, and this term will also give 0 because if you take x square minus y square common, you have uxx plus uyy. So definitely this also should satisfy the Laplacian equation. So those are zeros, and 2v minus 2v also gets cancelled. So which means you can see now vx if you take common, or 2 if you take common, you have x into vx minus y into vy, 4 times of this actually is equal to 0, which means you can clearly see this 4 can't be 0, so you can cancel this. X into dou v by dou x minus y into dou v by dou y is equal to 0, and that's exactly this option here. Okay, so x into dou v by dou x minus y into dou v by dou y, this is equal to 0. Okay, so that's how we can have this particular expression for this question. It's only partial differentiating twice of u. Okay, is that clear to all of you? This is a pretty much simple question to do. Clear? Yes or no? So please respond. Next, let's go for the next question. So there is one question from complex calculus as well. So limit z tends to e power pi I by 3 z cube plus 1 divided by z power 4 plus z square plus 1. Let us see the things. Limit z tends to e power I pi by 3 z cube plus 1 divided by z power 4 plus z square plus 1. This is what we have. Correct? Next, let us see here. Now, you know De Moivre's theorem, like e power I theta whole power n is equal to e power I n theta as long as this n is an integer. Correct? If you know this, then this question is very easy. This is the actual De Moivre's theorem, and it's clearly mentioned in the syllabus of XC Mathematics that there is this De Moivre's theorem in the syllabus. And also, you can find a comprehensive course on engineering mathematics on the same YouTube channel, which is done by me, and in that you can definitely find this if you have a look at that. Okay, there are two courses, like comprehensive course on engineering mathematics and also comprehensive course on basic thermodynamics. Those two courses are free and they are already available on this channel, so you can have a look at them when you find a bit of time. Next, so now if you substitute e power I pi by 3 directly, we get e power I pi by 3 whole cube plus 1 divided by e power I pi by 3 whole power 4 plus e power I pi by 3 whole square plus 1. So let us simplify the things. E power I theta whole power n can be written as e power I n theta. So 3 gets cancelled, and this is e power I pi. E power I pi is nothing but minus 1. So minus 1 plus 1, because you know e power I pi is nothing but cos pi plus I times of sin pi. Cos pi is minus 1 and sin pi is 0. So that's how you'll get this complete value as minus 1. Next, if you come here, e power I times of 4 pi by 3. Correct? So 4 pi by 3 is nothing but pi plus pi by 3. So cos pi plus pi by 3 is minus cos pi by 3, which is minus 1 by 2 plus I into minus root 3 by 2, and again plus this is cos 2 pi by 3, so which is minus 1 by 2 plus I into root 3 by 2 is the value of this plus 1. This is what we have, and you can see this gets cancelled, minus 1 by 2 and plus 1 gets cancelled, minus 1 plus 1 gets cancelled. So this is of 0 by 0 form, which means you can directly apply L'Hospital rule for the evaluation of this limit. Let us apply the L'Hospital rule. So if you apply the L'Hospital rule, e power I pi by 3 into L'Hospital of this is 3z square divided by 4z cube plus 2z. So you can cancel 1z whole over. So this is z square. So limit z tends to e power I pi by 3. What do you have? 3z divided by 4z square plus 2. This is what you have. So if you substitute directly, 3 times of e power I pi by 3, which is cos 60, which is 1 by 2 plus I into root 3 by 2 divided by 4z square. Z square is nothing but minus 1 by 2 plus I into root 3 by 2, because Z square is nothing but again e power this term which we wrote here 1 minus 1 by 2 plus I times of root 3 by 2, and we have plus 2 here. So this is the value of the expression that you need to find. So we can do one thing easily. First of all, 3 times of, look, this 4 into minus 1 by 2 and this plus 2 gets cancelled. So this term and this term gets cancelled, because 4 times of minus 1 by 2 will give you minus 2. So minus 2 plus 2 will go to 0. Again, you can cancel this 4 2 times here. So we'll get 2I root 3 in the denominator, and in the numerator we have 1 by 2 plus I times of root 3 by 2. This is what you have. So which means you can cancel this and you can write root 3 here. So 1 by 4 if you take common on a whole, 1 by 4 if you take common, also root 3 by 4 if you take common on a whole, because this 2 and this 2 gets cancelled. So 1 by I is minus I plus root 3. This is what you have, and you will see 3 by 4 minus I root 3 by 4. This is the value that you will have finally. Okay, this is just application of L'Hospital rule, and you could see clearly 3 by 4 minus I times of square root of 3 by 4. This is what you have. Okay, clear? This is a bit application of this L'Hospital rule in complex numbers, but that's not a new topic for us. This is the topic which we dealt many times in our lectures. Clear? Okay, so shall we go for the next question? Is that clear to all of you? Is that clear to all of you? So shall we go for the next question? Because you can see questions are not that lengthy, but of course they need a bit of concepts to be applied. Next, let us go for the next part. So there is one question again from two variable calculus or multivariable calculus. So f of x comma y is equal to x power 4 plus y power 4 minus 2x square plus 4xy minus 2y square plus alpha, of course. So this is what we have. Next, so they are asking you for, this is the real valued function, okay, then which one of the following statements is true for all alpha? Look, they are asking about the concepts of maxima and minima in the options, correct? And also saddle point is one such point where it's similar to the point of inflection in single variable calculus, correct? So now if you write p, which is dou f by dou x, if you write that 4x cube minus 4x plus 4y, and if you write q, this is dou f by dou y, which is again 4y cube plus 4x minus 4y. And clearly if you solve these two equations, definitely one solution of this is 0 comma 0, because yes, saddle point, it's correct. So that's why I have also mentioned this in a red color here. So definitely if you look at these two equations, one thing is very clear, this 0 comma 0 will be one solution of this, because both these are homogeneous equations, correct? I'm sorry, because of this x cube they are not homogeneous, but you can see there is no constant term involved in both these cases. So definitely 0 comma 0 is one solution. Now if you write q, which is, or let us write r, which is dou square f by dou x square. So if you differentiate this partially with respect to x, once again you will get 12x square minus 4, correct? Similarly, yes, which is dou square f by dou x dou y, which means if you differentiate this partially with respect to x, again you have 4, and t is nothing but dou square f by dou y square. Let us calculate these values. So if you partially differentiate this term, again we get 12y square minus 4. But of course if you calculate this value at the stationary point zeros, this is minus 4, this is already 4, and again this at 0 comma 0, this is also minus 4. So if you calculate, you can see clearly one thing, r is less than 0, and of course if you calculate rt minus s square, this is also equal to 0, which means one thing, this is the point where the second derivative test fails, and this is a point of saddle point for us. Okay, so 0 comma 0 is a saddle point, because we get this second derivative less than 0, and also this condition that governs the condition for maxima and minima is 0 at this case. Okay, so we can't decide. So basically this 0 comma 0 is saddle point. Clear? So that's how saddle point is the correct answer for this. Is that clear to all of you? Is it clear to all of you? Yes or no? So please respond. Is that clear to all of you? Fine. Okay, so let's go for the next question. So okay, I think engineering maths questions were done now. So now let's start solving fluid mechanics questions. Okay, clear, and I hope you enjoyed the mathematics sessions. So now let's start with the fluid mechanics. So straight away we'll go for the key, and then we'll also see for the detailed solutions of each and every question. Clear? So let's start solving fluid mechanics as well. So this is the first question that we have. Yeah, good. So let us try to solve the questions. So let us start solving fluid mechanics. A two-dimensional Eulerian velocity field is given by V bar is equal to, look, there is a velocity vector that's given. So V bar is equal to square root of 5 times x I bar minus, there is a minus sign over there, root 12 y j bar. Okay, so this is the velocity field that we have here. So if this is the velocity field, then they are asking you for what's the magnitude of acceleration in this case, correct? So the answer is 13, but of course let's see how it's 13 actually. So if you want to write the complete acceleration in the x direction, or let us write the components. So if you want this complete acceleration in the x direction, then this is nothing but rank questions was there, is it? But we couldn't find them. Anyhow, if there is something that sort of, we'll definitely provide something to compensate that. Okay, so no issues. So if this is your velocity vector, then clearly you can see here, this is your x component of velocity and this is your y component of velocity. Of course, let us retain a plus sign and then put a minus sign here. Okay, so now let us go here. So Ax is nothing but dou u by dou t plus u into dou u by dou x plus v into dou u by dou y plus w into dou u by dou z. This is what we have, of course, but you have this 0 and of course u is only a function of x, so this is also 0, and it's only a function of x, so this is also 0. So you have your Ax is equal to root 5x into dou u by dou x. If you differentiate this partially with respect to x, you have this root 5, so this is 5 times of x. So this is what you have for Ax, and the acceleration in the x direction is equal to 5 times of x. Similarly, if you go for the y direction or y component, Ay is equal to dou v by dou t plus u into dou v by dou x plus v into dou v by dou y plus w into dou v by dou z. This is what you have, right? And now one thing very clearly, this is a two-dimensional field, so this w is 0, and also you can see clearly this v is dependent only on y, which means this dou v by dou x and this dou v by dou t terms are 0, okay? So there is only some parting or something in the problem in the dou v by dou y term. So Ay is equal to v, which is minus square root of 12y into this dou v by dou y. Partial differentiation of this complete function with respect to y is minus root 12. So this is 12 times of y. So this you have Ax is equal to 5x units, and of course Ay is equal to 12y units. So this is what you have. So definitely if you try to calculate the net acceleration, they have given you the point x is equal to 1 and y is equal to minus 1. So at x is equal to 1 and y is equal to minus 1, this value at x is equal to 1, this is 5 units, and this value at y is equal to minus 1, which is minus 12 units. And of course, since acceleration, they are asking for the magnitude of acceleration. So these are two perpendicular components. So if you want the net acceleration, that is nothing but root of ax square plus ay square, which is root of 5 square plus 12 square, which is 13. So this is 13 units. So 13 units is the answer for this question, and of course this involves a bit of local or temporal acceleration plus convective acceleration, but of course here the temporal acceleration terms are 0 because here the velocity field is not time dependent. Is that clear to all of you? Okay. There is one more question in mathematics actually. Let me check. Okay. Let us see. Did I skip any question accidentally? This is the heading. Okay, fine. No issue. If there anyhow, we are about to launch this solution PDF of this complete XC paper. So in that you can definitely find. Okay, maybe by tomorrow. So anyhow, so this is how the answer for this fluid mechanics question is 13, because they are asking for the resultant of the acceleration, and Ax and Ay are two mutually perpendicular components. So definitely the magnitude can be written as root of ax square plus ay square, which is root of 5 square plus 12 square, which could give you 13. Okay, so this answer is 13. Next, let us go to this question. If P inlet is equal to 1.2 pascals and P outlet is equal to 1 pascal are the average pressures at the inlet and outlet respectively for a fully developed flow inside a channel having a height of 50 centimeters. So now see clearly, there is one channel clearly given. There is one channel in the sense edges are fixed. So this is something, this analysis or this flow is something similar to the Cauchy flow which we deal with, correct? So here they have given the pressure inlet. Let us change the let us write the data with some different thing. So inlet pressure is average inlet pressure is 1.2 pascals. Pressure P out is equal to 1 pascal. Correct? So this is what we have. Are the average inlet and outlet pressures for a fully developed flow. So the flow is fully developed inside this, and inside a channel having a height of 50 centimeters. So basically this channel height that you have here is 50 centimeters. That's okay. Then the absolute value of average shear stress in pascals acting on the walls of the channel length 5 meters. So this channel length is also given. This is 5 meters, correct? So this is something similar to the Cauchy flow, and in Cauchy flow we generally analyze the situations in this way. So you will take a midplane about this, and let us consider this as your x-axis and this as your y-axis. So if you want the shear stress distribution in this, you know it's linear distribution. So definitely it looks something like this. If you try to appreciate the shear stress distribution inside this, so this is how the shear stress gets distributed, correct? So if you want the shear stress average at wall, so they are asking you at wall acting on the walls. So they are interested about this value. So if they want this value, shear stress at wall is equal to minus dou p by dou x into the distance of the wall from this reference, which is half of this channel length. If you call this as h for example, then this is h by 2. Okay, total channel length is h, so this is h by 2, and this is a linear shear stress variation. So now dou p by dou x. What is this dou p by dou x? Look, P outlet minus P inlet, which is 1.0 minus 1.2 divided by that pressure is changing from 1.2 to 1.0 within a span of 5 meters. So we know this total length here is 5 meters into h by 2. You know h is 50 centimeters, which is equal to 0.5 meters. So this is 0.5 divided by 2. So this is the calculation that you need to perform carefully. So minus of this minus 0.2, which is 0.2 by 5 into 0.5 by 2. This is what you have. So this is 0.1 and this is also 0.1. So 0.1 into 0.1 will give you 0.01, and this is shear stress. So the units are pascals. So 0.01 pascals. Okay, yeah, they are asking you in pascals, so no issue. 0.01 is the correct answer in this case. Okay, this is a simple Cauchy. Of course, it's not a simple, it's a general Cauchy flow, but of course there is some pressure gradient which is constant in this direction. Clear? So it's a simple question that you can perform, and 0.01 is the answer for this. Okay, let's go for the next question. So this is one question that we have. A spherical ball is steadily supported against gravity by an upward air jet as shown in figure. So you can clearly see there is some air jet that's going up in this direction, and this ball, this spherical ball, is supported in air because of this force exerted by this air jet. Next, take acceleration due to gravity to be g is equal to 10 meters per second square. Okay, so g they are asking us to take 10 meters per second square. The mass flow rate of air reaching the ball is 0.01 kg per second. So if you take the mass flow rate of air, m dot is equal to 0.01 kg per second. Okay, this is also fine. So, and the air reaches the ball at an upward velocity of 3 meters per second. So at the velocity at this point of contact or at this region, this is 3 meters per second. So let us write v is equal to 3 meters per second. This is also fine. Now, neglecting the buoyancy forces and using the principle of integral momentum balance. Look, one thing is very clear, this buoyancy force is asked to be neglected, so we can't write any equations or any expressions that's related to buoyancy of the ball, buoyancy of this fluid on this ball, and also using the principle of integral momentum balance. Now, one thing is clearly indicated in the question, this is the momentum balance he has to be applied for getting the mass of the ball, correct? Because they are asking you at the end the mass of the ball in grams, of course. So one thing is very clear, if you apply only and only momentum principle, then one thing is clear, the weight of this ball has to be balanced by this air jet force, correct? And you know clearly, if there is some m dot mass flow rate of air that's flowing with a velocity v, then one thing is very clear, if you want to have this momentum balance in the y direction, of course, y I mean in this direction, then definitely you can see this air jet is intended towards the upward direction. So m dot into v is the force exerted by this air jet on this ball, and the downward force is the weight of the ball itself minus mg is equal to 0, and m denotes the mass of the ball actually. This is of ball mass. So now see carefully. Mass flow rate of air is given 10 power minus 2 into the velocity of the stream of air is also given, which is 3 meters per second, minus, or let us write equal to mass of the ball, which is not found, into acceleration due to gravity, which is 10. So you can see clearly mass of the ball from this expression is equal to 3 into 10 power minus 3 kgs, and you know if this is 10 power minus 3 kgs, we can simplify this expression in grams, which is equal to 3 grams, correct? So this mass of the ball is 3 grams. That's what we can have, and this 3 is in grams. Okay, so you can see clearly in grams they are asking. So the mass of the ball that this air stream is holding with in the air is 3 grams. So mass of the ball is equal to 3 grams. Okay, next let's go for the next question. These are pretty much a bit easy questions to deal with, but of course, again, your calculations need to be a bit careful while performing all these questions. So let us try to solve this. In a Cartesian coordinate system, a steady, look, these words have to be made a note of. Steady in the sense there is no effect of any property with respect to time. Incompressible, so density doesn't change at any point of a Newtonian fluid. This is also a Newtonian fluid, is given by velocity profile is given. So V bar is equal to U naught into 1 minus A y square I bar. This is the velocity profile that's given. Okay, where V is the velocity vector and I is the unit vector in the x direction. So U naught is a positive real constant in meters per second and A is a positive real constant. So this A is positive and U naught is also positive. The viscosity of the fluid is mu in Pascal second. The absolute value of the pressure gradient. So thermal answer key, yeah, definitely after this fluid mechanics session, we'll maybe by tomorrow we can have this thermal key also ready. So no issues. Clear? So anyhow, let's work out this question first of all. So one thing is very clear. In this pressure gradient is involved and also this viscous forces are involved because of this mu. Now, please tell me if both mu is involved and also if this pressure gradient is involved, what equation can I use here? Look, viscous forces are also of importance and also pressure gradient is also of importance. Now, tell me what the equation I can use here. Can I use the Navier-Stokes equation? Yes or no? Can we use the Navier-Stokes equation? Please respond. Can we use the Navier-Stokes equation? Because it's clearly given there is some effect of viscosity on the path, on the flow, and also there is some pressure gradient that's existing. Yes? Can I use Navier-Stokes equation for the solution of this? Yes or no? So please do respond. We can use, correct? So if you try to write the Navier-Stokes equation in the x direction, then you have rho times of dou u by dou t plus u into dou u by dou x plus v into dou u by dou y plus omega into w into dou u by dou z. This should be equal to minus dou p by dou x plus mu times of dou square u by dou x square, because basically your equation will be u into del square v is what you have, and del square v in the x component will give you del square u by del y square plus del square u by del z square. This is what you can have in the as the Navier-Stokes equation for the x direction, correct? So if this is the Navier-Stokes equation in the x direction, of course for a steady incompressible flow, then one thing is very clear, the flow is one dimensional here in this case, so v, w are zeros, and this is also a fully developed flow, so definitely we can neglect any changes of velocity in the x direction, and it's given it's steady flow, so there is no effect of this. So anyhow, so you can clearly see that this is independent of x and z, so these two are zeros. So if you take all these terms to be zeros, then one thing that you have is dou p by dou x or del p by del x is equal to mu times of dou square u by dou y square. This is what you have, correct? So this is the pressure gradient in the direction of flow. Of course, we are considering the x direction as the direction in which flow is happening. So del p by del x in this direction is nothing but mu times of dou square u by dou y square. So this is equal to mu times of dou by dou y of this particular thing. So which is u naught into minus 2ay. Correct? Because if you partially differentiate this with respect to y, u naught is a constant and the partial derivative of 1 minus ay square will be minus 2ay. So this is what you have. So once again, if you differentiate partially with respect to y, this implies mu into, if you differentiate this partially with respect to y, u naught into 2a is what you have, of course with a minus sign. But here in the question they are asking you for the absolute value. So in the options you can see they didn't give any minus sign at any point. So they are asking you for the absolute value. So they are asking you for del p by del x modulus. So which means the modulus of this value, which is mu times 2a u naught. Okay, or 2a mu into u naught, both are same. So definitely this is the pressure gradient in the direction of flow for this particular given situation of velocity vector. Is that clear to all of you? Look, anytime you please try to do one thing, write the fundamental equations, then try to approximate few things. Okay, so this is the fundamental equation that involves pressure gradient, viscous forces and all. But of course, depending on the velocity profile and all, you can neglect or you can eliminate few terms out of this. Okay, but this is the classical Navier-Stokes equation, which you know very well. Okay, clear? Yes or no? Is that clear to all of you? Okay, so let's go for the next question. Okay, water discharges from a cylindrical tank to an orifice as shown in the figure. Yeah, you can see there is some water in the tank. So there is some level of water initially in the tank, and this water is getting discharged from this orifice, which is here. Next, the flow is considered frictionless. Initially, the water level in the tank was h1 is equal to 2 meters. So you can see there is a h1 here, and this is the initial level of water in this tank. Now, the diameter of the tank D is 1 meter, so they have denoted this diameter with capital D, while the diameter of the jet D is 10 centimeters. So, this jet which is coming here, this diameter is also given, which is 10 centimeters. And the acceleration due to gravity is G is equal to 10 meters per second square. This is what we have. The time taken in seconds up to 1 decimal place for the water level in the tank to come down to H2. So, this is H1, but this is H2. Okay. So, they are asking you what's the time required in seconds for bringing this water level from H1 to H2 when some water is getting out to this exhaust. Exit. Okay. So, let us try to have some clear idea on this question, because questions of this kind are very common in many exams. So, please let us spend a few minutes on this. Look, let us suppose there is a tank which has a little orifice at the bottom. Okay. Of course, this line has to be straight. So, okay. So, let us suppose this is the water level at any instant H or at any instant T. Okay. And now, you know this velocity, if you apply the Bernoulli equation, you will easily get this velocity is nothing but square root of root 2gh. Square root of 2gh. Okay. So, just apply the Bernoulli equation at these 2 points. You know that the velocity of exit at this point will be square root of 2gh. That's fine. Now, let us take this volume as control volume and let us apply the mass balance equation. So, let us suppose this is your control volume and let us apply the mass balance for this control volume. Okay. Now, one thing is very clear, whenever the flow is steady or whenever the situations are steady, one thing is very clear, your mass flow rate in minus mass flow rate out. This should be equal to a rate of change of mass inside the control volume. Correct? Will you all agree with me if I say this? The mass flow rate that's entering in minus the mass flow rate that's going out. Both these things should be equal to d by dt of mass within the control volume, or the time rate of change of this mass within the control volume. If this should happen, now whenever the tank is getting emptied, there is no mass flow rate into the tank. There is only something that's going out. Yes. So, this implies minus rho, mass flow rate that's going out is rho into discharge, which is area, which is the area of the tank or the area of the aperture that's coming out. So, area of the jet into velocity at which it is coming, which is square root of 2gh. This is equal to d by dt of mass inside the control volume. At any instant, if this is the area of the tank, then density into area of jet into the instantaneous height h at any time. This is what we can have, and of course, since the fluid is same in both the cases, we can cancel the densities. So, this implies minus a jet divided by, look here, this is actually tank area, because the control volume that we are considering is of tank. So, this a tank, if it comes down into square root of 2g is equal into dt is equal to 1 by root h dh. This is the standard differential equation for any water exiting the case. Next, so now all these things are constant. So, if you integrate this within two limits, like generally at time t is equal to 0, your initial height of water is equal to h1, and at time t is equal to t, your initial height of water is equal to h2. This is what you will be having. So, this implies minus a jet divided by a tank into root 2g into time t. This is equal to, now if you integrate this is h power minus 1 by 2. So, we will be getting, if you integrate h power minus 1 by 2, if you integrate, then you will be getting h power minus 1 by 2 plus 1, which is root h 2 times of this, which is h1 to h2. So, if you can cancel this root 2 and you can put a 2 here. So, definitely you can get the time t as root 2 times of root h2 minus root h1. Of course, this minus sign goes to the right hand side into a tank divided by a jet. And of course, we have root g here. Okay. So, this is the expression for time that is taken for the fluid. So, this is the time that is required for the fluid to reduce from height h2 to h1 whenever the tank area is given by a tank and the jet exit jet is given by area a jet. Okay. So, this is the final expression that we have, and this I have told you because this is this kind of questions that emptying a tank in some time are quite common in many exams. So, that's why I had just given you some 3-4 steps, 1, 2, 3 hardly. That's a common step that of your knowledge, and this is what we have. Okay. So, now you have your values here. So, t is equal to let us write here. So, t is equal to minus square root of 2 by g into, we have something a, okay, area of tank divided by area of jet, area of tank divided by area of jet into root of h2 minus h1. Here all the things are given to you. So T is equal to minus root 2 by 10 into area of tank divided by area of jet is nothing but diameter square of tank divided by diameter square of jet. So d tank divided by d jet whole square into square root of h2. Initially or final height they are reduced to 1 meter minus root 2, and because of this minus sign here, this gets a positive value totally. So time t, if you calculate this value by putting 2 by 10 into diameter of tank is given 1 meter, whereas the diameter of jet is also given, which is 10 centimeters, which is 10 power minus 1 whole square into, because we eliminated this minus sign, this is root 2 minus root 1. Okay, so this is the formula for the time taken, and just if you apply these things, then this could give you something around 18.524 seconds. Okay, so this is the time that's required for this tank to maintain its level from 2 meters to 1 meter under these conditions. Okay, so that's why the answer is 18.5. So since they asked you to round off to 1 decimal place, you can enter 18.5 here. Okay, the normal calculations could give you something around 18.524. Clear? I just told you this because these kind of questions are very common in examinations, and you need not remember, or you need not do very much to remember this formula. It's just 3 steps. That's it. Okay. Clear? This is fundamental mass balance equations. Okay, is that clear to all of you? Shall we go for the next question? So this is 18.524 seconds is what you need for bringing this water level from 2 meters to 1 meter. Next, let us see this question. Let us see this question. So the two-dimensional velocity field V bar of a flow in a Cartesian coordinate system is given in dimensionless form. So V bar is given, this velocity field is given as x square minus axy I bar plus bxy minus y square by 2 j bar. This is what we have. Correct? This is what we have. Now, here I and j are the unit vectors along x and y directions respectively. A and B are independent of x, y and time. So basically these are constants. They are independent of the space and also they are independent of time. So if the flow is incompressible, this has to be made up. If the flow is incompressible, then the value of A minus B up to 1 decimal place is what they are asking you. Look, they are clearly telling you that the velocity or the flow is incompressible. Whenever the flow is incompressible, definitely the velocity vector should satisfy the condition. This divergence of V bar is equal to 0. Okay? And we call, if there is some divergence vector 0, means if divergence of some vector which is 0, it's quite common for us. We call those vector fields as incompressible vector fields or solenoidal fields. Correct? So let us write this. Dou by dou x of this term, which is x square minus axy, plus dou by dou y of this value bxy minus y square by 2. This has to be 0. Okay? So this is the condition that's governing with us because it's clearly given the flow is incompressible. So we can write these equations. So dou by dou x of this, which is 2x minus ay, plus dou by dou y of this term, which is bx minus y, is equal to 0. So let us write the coefficients of x, 2 plus b minus plus y into, or let us write minus y into a plus 1 is equal to 0. So if this has to be 0, then individually this constant terms has to be 0. So this 2 plus b has to be 0 and also this a plus 1 has to be 0. So b is equal to minus 2 and a is equal to minus 1. So a minus b is what they are asking you for. So minus 1 minus of minus 2, which is 1, is the correct answer in this case, which we have shown here, 1.0. Clear? Since they have given you the flow field is incompressible flow field, then definitely its divergence of this velocity vector has to be 0, and you can clearly see this dou u by dou x plus dou v by dou y terms I have equated to, the summation of these two terms I have equated to 0, and this is what the values will get. So a minus b value is 1.0. Is that clear to all of you? Is that clear to all of you? So please respond. Please type in the chat box. Is that clear to all of you? Okay, so let's go for the next question. This is a very simple question from surface tension. So one thing that we can see, the absolute value of pressure difference between the inside and outside of a spherical soap bubble. This has to be made a note. Spherical soap bubble of radius r and surface tension gamma is dash. So for drops or for droplets, look, if you have some surface like this, then if these are the radius vectors that's connecting these points, if this is R1 and if this side is R2, then definitely, and of course, if these are the surfaces on which the surface tension is pretty much effective, so if you take this surface, some part of any droplet or bubble, so for droplet, you know, if this is P inlet or this is P out, which is on the outside of the bubble, then you say this definitely this P in is more. You can see the bubble gets bulged out, correct? So this delta P, which is basically, of course, P in is more. So P in minus PO or delta P is given by sigma into 1 by R1 plus 1 by R2. But of course, this is the case of a droplet. But for bubbles, since you know, for bubbles we have two surfaces in contact. For bubble, this delta P is equal to 2 times of sigma into 1 by R1 plus 1 by R2. This is what we'll be having. Of course, sigma I mean surface tension, but here in this case they have mentioned the surface tension with gamma generally. Okay, so anyhow, let us take the gamma. So 2 times of gamma into, now whenever the bubble is a spherical soap bubble, you know, this R1 and R2 will be same, which is equal to the radius of the bubble, correct? So we can take this as 2 by R, and that could give you 4 gamma by radius of the bubble, okay, which you can see in the first option here straight away. So this is a generic expression, look, which can, this P in minus P out, which is the pressure difference between these two surfaces, is given by that expression in case of a droplet, because you have only one free surface or one surface of interface between the surface of liquid and A, and of course here in this case you have two surfaces simultaneously because some part of the A gets interlocked in the bubble. So you can write 2 times of sigma into 1 by R1 plus 1 by R2, and since this we are dealing with soap bubble, all these radius of curvatures are same and they are equal to radius R of the bubble, okay. So definitely we can use this expression, and this is equal to 4 sigma by R, which we have here, okay. Is that clear? Of course, this is one simple question that you can always recollect from basic formulas. So still there are 15 questions left. So shall we go ahead? Shall we go ahead? All of you, please do respond. Let us quickly go to the next question. So this is a very simple question. The general relationship between shear stress and the velocity gradient dou u by dou y for a fluid is given by tau is equal to some constant into dou u by dou y whole power n. Okay, then where k is a constant with appropriate units. The fluid is Newtonian. If you know one thing, of course, for Newtonian fluids, in a simple case, we have this tau is equal to mu into dou u by dou y, correct? But of course, this is valid only for a simple Corti flow, but not in general, because you know, in general, this tau is proportional to shear strain, rate of shear strain, correct? But of course, in case of a simple Corti flow, you will get this tau is equal to mu times of dou u by dou y. So now, anyhow, you know this power is 1 here in case of a Newtonian fluid. In case of a Newtonian fluid, you have this linear, this dou u by dou y whole power 1. So if you try to plot this dou u by dou y means the velocity gradient on the one axis, and if you want to plot a shear stress on other axis, it's quite from our experiments that we have a straight line that's passing through like this. Let us draw a proper straight line. So something like this, okay, and this is given by tau is equal to mu into dou u by dou y, and this viscosity is generally treated as constant. So if you try to plot tau and dou u by dou y for Newtonian fluid, the line passes through origin, okay, because this is of the general form y is equal to mx, okay, clear? So obviously your n value is 1 in case of a Newtonian fluid, which is given here, okay. So this is what we can have all the time for Newtonian fluids, n is equal to 1. Next, let us go to the next thing. A large pump is to deliver oil at an average velocity v of 1.5 meters per second. So v of the pump, or the large pump, is to deliver oil at an average velocity of 1.5 meters per second. So it is delivering oil at a velocity of 1.5 meters per second. The pump has a impeller diameter of d is equal to 40 centimeters. So there is a big impeller diameter whose diameter is 40 centimeters, and the pressure rise across the pump is 400 kilopascal. So delta P for the pump, this is equal to 400 kilopascals. This is also given. To design this pump, a lab scale model pump with an impeller diameter of 4 centimeters is to be used with water as a fluid. So generally, you know, in labs we don't have the enough space to create the actual prototypes. So what we do, we generally scale them and we create some models, correct? So that's why they have also given you this. They have created one model such that this diameter of the model is equal to 4 centimeters. Okay, so for actually a 40 centimeter diameter pump, this impeller they have designed with 4 centimeters model. Then what's the data that they have given? Here they have used oil as the fluid, and of course here they are using water as the fluid. This is what they have given you. Okay, then the viscosity of the oil is 100 times that of water. So one thing is given, the viscosity of oil is 100 times of that of water. This they have given. Okay, next, and the densities of oil and water are identical. So density of oil is same as density of water that we have. Or else let us write water, because we are not much into chemistry anyhow. So let us write water. So this is what we have. So anyhow there is no effect of this densities, because both are having similar densities. A complete geometric similarity is maintained between the model and the prototype if the pressure rise is function only of V, D, rho and mu, the respective pressure rise across the model. So they are asking you, look, we can analyze this situation. Basically there is a big pump which is delivering some pressure difference of 400 kilopascals, at this velocity of 1.5 meters per second. But at the same time in lab we are testing it with a 4 centimeter impeller diameter and of course with a different fluid which is water. Correct? So now let us get back to the situation. One thing is very clearly given, this delta P is a function of mu, V, rho and mu. Correct? This is what is given clearly in the question. So if clearly in the question if it's mentioned that this pressure change is only a function of mu, V, rho and mu. Now one thing you can clearly, this density of model fluid is same as density of fluid that used in the prototype. Yes or no? It's clearly given. You can see clearly from the question. Let us highlight the portions. It's clearly given. The densities of oil and water are identical. So the density of the fluids that used in the model and prototype are equal. Okay. So now let us compare. Which means this density has not much significance here. So which means this delta P is just a function of mu, V and this is actually D diameter, because we are repeating mu 2 times. So this is what we have. So pressure delta P units is nothing but force by area. So we can write m L power minus 1 T power minus 2. This is what we have. And of course mu, we have the dynamic viscosity which is m L power minus 1 T power minus 1, because mu is nothing but again tau is equal to mu into dou E by dou y is what you can write. So if you work out the dimensions you will get something like this. Velocity is L T power minus 1 and dimensions of D is nothing but L. So these are the things that you have. So definitely if you have this, then your delta P should be dimensionally equal to some function m L power minus 1 T power minus 1 whole power A into L T power minus 1 whole power B into L power C. And you will be getting 3 unknowns and 3 equations, because you are dealing with 3 fundamental equations. So one thing you will get, delta P is equal to V or else mu V by D. This is what we will be getting. Ragish Sharma, yeah, okay. So see here, this is what you will be getting, but of course here not the exactly equal to sign, it turns out to be something like this. So now you can write delta P of model divided by delta P of prototype. This will be equal to mu model by mu prototype into V model divided by V prototype into diameter of prototype divided by diameter of model. This is what you will be having. And of course values are very much given. It's clearly given. This is 100 and velocity of model is just, it follows the length scale again. So this is 1 by 10 and of course this value diameter, this is around diameter is given. How much is that given? So we can see clearly the diameter of 4 centimeters here, and of course this is 40 centimeters. So they have given 40 centimeters here, diameter of the main prototype fluid, and this is 4 centimeters. And of course this gets cancelled and sorry. Just a second guys, please. Okay, fine. So this is what you will be getting, and then if you perform this analysis a bit carefully, let us work out these things. Anyhow, we have this dimension, so let us quickly work out this, because writing directly even could affect sometimes. So let us have a step-by-step analysis for this dimensional analysis. So now let us compare the just a second guys, this port. Okay, so let us perform this dimensional analysis now. M L power minus 1 T power minus 2 is equal to, look, M power A into L power minus B, okay, minus A plus B plus C. This is what you have, and of course T power minus A minus B. This is what you will be having, correct? So now let us compare the things. So A is equal to 1 and minus A plus B plus C is equal to minus 1 and minus A minus B is equal to minus 2. So A is equal to 1, so minus B is equal to 1, A is equal to 1, so minus 1 is there, so B minus B is equal to minus 1, so B is equal to 1. So if A is equal to 1 and B is equal to 1, then let us see C, then this gets cancelled and C is equal to minus 1. So this is what you have. So finally this expression is for mu and this is for V and this is for D. So if you write the things, we have delta P is proportional to this is mu V by D. This is what we have initially, correct? So this is proportional to mu V by D. So let us do these things for prototype and model as well. So delta P is proportional to mu V by D. So let us write delta P of model divided by delta P of prototype. This is equal to mu model by mu prototype into next V model by V prototype into, since diameter is in inverse, we can write diameter of prototype divided by diameter of model. So this is what we have finally. Okay, and here things are very much clearly given. So velocity of dynamic viscosity of model is clearly given here. So see here, the viscosity of the oil is 100 times that of water. So basically oil is used in the prototype, so you can clearly write this value is 100 times of mu model. Okay, so which means we can cancel these two and this expression, or else let us write delta P of model by 400. This is equal to 1 by 100 into velocity of model divided by velocity of prototype. You know, length scale is strictly followed, so definitely this has to be 1 by 10th of this, so 1 by 10 into diameter of prototype is 40 and the diameter of model is 4 centimeters, of course. So this is what we have clearly. So if you perform this calculations, 40 gets cancelled and this gets cancelled. So delta P of the model is equal to 4 kilopascals. So the final pressure that the model can reach or the buildup within the fluid is 4 kilopascals. Okay, for a given initial of 400 in this case. So 4 is the correct answer. The only thing you need to be a bit careful of this dimensional things and solving these equations. If you can solve these equations correctly, that's it. That's more than enough to solve this question. Okay. Because you know length scale will be same as the velocity scale, because even V consists of only one L, T power minus 1. So this length ratio and this velocity ratio both are to be identical in general. Okay. Clear? Did you all understand how this is for? Is that clear to all of you? It's a basic fundamental application of dimensionless terms and that's it. And everything, the data that is here that I substituted is given in the question clearly. Okay. So the actual pressure that is developed by the prototype is 400. So you will be ending up with 4 kilopascals if you perform the calculations correctly. Clear? Okay. Is that clear? So shall we go for the next question? We have solved some 9 questions still here. So we have some 11 more questions, 13 more questions to go. So shall we continue? Yes or no? So please respond. Shall we continue? All of you please do respond. Shall we continue? Okay, anyhow, let's go for the next question. So see here. For the configuration shown in the figure, oil of density 800 kg per meter cube I'm sorry, this is kg per meter cube because it's density. So lies above the water of density 1000 kg per meter cube. You can see clearly in this configuration there is some oil which is above this water. Okay. Now assuming hydrostatic conditions and acceleration due to gravity g is equal to 10 meters per second, and one thing is clear, it's given hydrostatic conditions, which means the fluid is static. The length L in meters up to 1 decimal place. So this is 30 degrees is what it's given. So 30 degrees, and they are asking you what is the length of this L in the column. Okay, so let us apply the static pressure balance above this section. Yeah, 70 plus is always a good score to get top IIT Srinivas, because in XC generally 70 plus marks could give you something around top 10 since till last year, because there is one big change in this year. I want to tell you, till last year the number of aspirants that gave XC exam was around 3,600, okay, or hardly 3,700. But this time, since IIT Bombay has given opportunity for writing 2 papers, so many of them have opted for XC along with their main course stream like mechanical or some other branches. Okay, so please try to have 70 plus is used, but till last year. But this year, let's see what are the situations. Okay, because number of aspirants that write the exam got almost increased by 10 times. So we need to see what's the situation. Okay, because this situation is even new for many of us. We didn't see this before. Okay, for XC. Anyhow, let's get to the questions. Fine. So let us see this. If you apply the static pressure balance till here, this is P atmosphere. So P atmosphere plus oil is of density 800 kg per meter cube, and this is of 0.5 meters width height. Okay, so there is some oil column of height 0.5 meters, and this density of the oil that we are using is 800 kg per meter cube. So let us write the pressure column due to this oil is density of oil, which is 800 into G, which is 10 into this height is 0.5, plus the fluid column, which is the water column, which is here, is again of density 1000 into 10 into 0.5. So this should be equal to this P atmosphere plus again this water column is of equivalent height, which is equal to something like this. Okay, so if this is L, then this H value is nothing but L into sine theta, which is L by 2. So L by 2 G into which is L by 2 G into density of the fluid is 1000, 10 cube. Okay, so density into 10 into equivalent height. So this is L by 2. So if you just simplify this equation, you can get what is the value of L. So let us calculate quickly. So P atmosphere gets cancelled on both sides. Then acceleration due to gravity can cancel in all the terms. And of course, 800 into 0.5 is 400 plus this is 500 is equal to 1000 times L by 2. This is what you have here. Correct? So 400 plus 500, which is 900, and things like this. So 2 zeros, 2 zeros, 2 zeros we can cancel. So 9 into 2, 18 by 10 is equal to L, which is L is equal to 1.8 meters is the length of the water column inside this inclined tube. What IIT can I expect with 62 marks? Normally there are two, there are some 3-4 good IITs which are accepting this XC score, but of course one specific thing they are mentioning, normally if you go to your core branch score, they don't conduct any interview, but generally if you go to the XC score, they conduct an interview for many of the branches, okay, or many of the specializations for your masters, okay. And IIT Madras, my IIT, and IIT Bombay is also giving good branches, core branches for this XC score. So the one thing I would like to tell you is please wait peacefully till the rank card is out. So once the rank card is out, you can just know many other things, okay. So anyhow, the answer for this question is 1.8 meters. As we can see here, we are done with 1.8 meters. Clear? Is that okay to all of you? Next, let's go for the next question. Okay, there is one question. This is the question, right? Yeah, we solved this. Then this is the question. Water is flowing with a velocity rate with a flow rate Q in a horizontal circular pipe. So you can see there is some velocity, some discharge of Q in a horizontal circular pipe. Due to the low pressure created at the venturi section, obviously here the velocities will be maximum, so definitely pressures fall. Water from a reservoir is drawn upward using a connecting pipe as shown in the figure. So definitely you can see because of some pressure drop here, some water is picked up from this reservoir through this tube or to this pipe. Next, as shown in the figure, take acceleration due to gravity as G is equal to 10 meters per second square. So G they are asking you to take for 10 meters per second square. The flow rate Q is equal to 0.1 meter cube per second, and D1 is equal to 8 centimeters. d2 is equal to 2.20 centimeters. Okay, this is fine. The maximum height up to 1 decimal place of the venturi from the reservoir just sufficient to raise the liquid. So see here. This is what we have. Here they are asking you what could be this maximum height of the pipe, H maximum. So they are asking you what could be the maximum height of the pipe. Then look carefully. One thing is very clear, as we keep on increasing the height of this pipe, the velocity keep on decreasing, and finally at the point of maximum height, at least the liquid should touch this venturi. Yes or no? I took G is equal to 9.81 and got 19.6 as the answer. Is it correct? Okay, it depends on the range. So let us wait for 2-3 days more peacefully, because IIT is going to launch their official key and question papers. Okay, because until and unless IIT launch the official key, we don't know what is the exact range that will be provided by them. But of course, they do take these things into consideration, and they give a range such that even if you take 9.81, the values will fit within the range. Okay, so no issues, Tushar Pandey. Anyhow, let us continue. So see here. So one thing is very clear. Here the pressure is P atmospheric pressure, and here also the pressure is P atmospheric pressure. And of course, here definitely the pressure is something which is less than atmospheric pressure, which is very much known to us. So definitely, if you apply the Bernoulli equation at these 2 points, one thing is very clear. Here it's a reservoir and its velocity is 0, means the movement of this free liquid surface will be almost negligible. And also, whenever this height is H maximum, the fluid just raises and it just touches the venturi. That's it, correct? So which means by the moment the H height is maximum, here the velocity at this point will almost be very small, which is negligibly 0. Next, so if these are the 2 points that you can understand, then one thing is very clear. If this is section 1 that you are calling, and if this is P1 pressure, then we can write the difference of pressure between these 2 sections, means P ATM at this point and P1. This will be equal to rho GH. Correct? This is the equation. Correct? P ATM minus P1 is nothing but rho G into this height of the pipe H. Now let us apply the Bernoulli equation at these 2 points. So if you try to apply P1 by rho G plus, anyhow, at this point where the fluid is just touching, the velocity is almost small, negligible, and here you can write this as V1 square by 2G plus Z1 is equal to P2, which is P ATM by rho G plus V2 square by 2G plus Z2. This is what we can write here. And of course, both these are at same level, so no issues, we can cancel. And P ATM minus P1. Look, let us frame this equation. P1 by rho G plus V1 square by 2G. This is equal to P ATM, which is the pressure at the second section, by rho G plus V2 square by 2G. This is what we have, the application of Bernoulli at all these points. Correct? Now one thing is very clear. This P ATM minus P1 by rho G is equal to V1 square minus V2 square divided by 2G. This is what we have. And the expression for this is nothing but the height H. Correct? H maximum at this case, because we have clearly seen when you apply the Bernoulli between these 2 points, you have attained this relation. P ATM minus P1 is equal to rho GH, which means here in this, instead of this term P ATM minus P1, we can substitute rho G, and this is what they are asking you for exactly. Correct? So let us frame an expression for this: 1 by 2G into V1 square minus V2 square. Okay, and of course, V1 is maximum out of the 2 venturi section, so V1 will be definitely greater than V2, so this could give you a positive value definitely. Correct? So now how to calculate this V1 and V2? Mass flow rates are given, the discharge is given, and of course this diameters at these sections D1 and D2 are also given. At the same time, discharge is also given, 0.1 meter cube per second. So you can just calculate the values. V1 is equal to Q by A1, which is 0.1 divided by pi by 4 into diameter at section 1, which is now is 8 centimeters, so 0.08 whole square. Similarly, V2 is equal to Q by A2, which is 0.1 divided by pi by 4 into 0.2 square. This is what we can have. So definitely these are just 2 numerical values, and if you calculate, you will get what is V1 and what is V2, and G is equal to 10. So finally, if you substitute, you will get 19.3 something. Okay, 19.3, yeah, 19.3. This is what we got generally when we calculated. So H max is 19.3 meters. Okay, these are 2 simple equations that you can perform always. If you want, I can perform for you. So 0.1 divided by pi by 4 into 0.08 whole square. So 0.1 into 4 divided by pi divided by 0.08 square. So this is 19.894. So this velocity is 19.894 meters per second. And what about this? You can calculate quickly. 0.1, okay, into 4 divided by pi divided by 0.2 square. So this is what we have, 3.183 meters per second. So these are the two velocities at these two sections. So V1 is available with you, V2 is available with you. So 1 by 20 times of this complete value. Or else if you want, I could just show this for you. Square of this, of course, with a negative sign, plus we have 19.894. Okay, so plus 19.894, okay, 4 square. This is what we have. So divided by 20. So this is 19.28. So since they asked you for rounding off 1 decimal or something, you can write 19.3 meters. Okay, so basically this value is 19.28 meters around. So 19.3. Clear? This is a simple question, just application of Bernoulli's things. The only thing that you need to understand is, look, when you apply the moment you apply the Bernoulli's equation between these 2 points, let us, oh, I'm sorry. Okay, so this is 19.28 meters anyhow. Okay, the only thing that you need to understand, when you apply the Bernoulli's equation between the venturi inlet, I mean through the pipe, and of course at the reservoir facing, then you need to observe that velocities at both these points have to be 0, because as the height increases, the velocity through which the fluid rises decreases, and at the point of maximum height, the fluid just get lifted through the pipe and it just touches the venturi. That's the only thing. Okay, if you can understand that thing, then this is a clear intuition, and the answer will be 19.3 meters. Clear? Okay, so shall we go for the next question? So please do respond. Shall we go for the next question? Is that clear to all of you? Fine, let's go for the next question. Oh, I think we moved in a hurry. Okay. Okay, yeah, fine. Then this is the question. Water discharges steadily from a large reservoir through a long pipeline as shown in the figure. The das's friction factor in the pipe is 0.02. Okay, so since there is some flow, it has some friction. The pipe diameter is 20 centimeters. Okay, so this diameter is 20 centimeters. It's given, very good. The discharge of water is 360 meter cube per hour. So one thing it has to be made a note of is the discharge Q is equal to 360 meter cube per hour. This is what they have given you, correct? So generally we deal in seconds. So 360 divided by 3600 seconds for 1 hour. So meter cube per second. This is what we have. So this is 0.1. So discharge is 0.1 meters per second. Fine. So this is the discharge. Next. Water level in the reservoir is 10 meters. You can clearly see there is a water level which is of 10 meters. Then, and acceleration due to gravity G is equal to 10. So this G value is 10 meters per second square. This is also fine. If minor losses are neglected, so basically you have some anti-losses and all, so they are neglected. The length in meters up to 1 decimal place. So they are asking you, you got 187.4. Okay, anyhow, let us solve the things. So this is 10 meters per second square. Next. So if you apply the Bernoulli's equation at these 2 points, which is of interest, this point and this point, then look, P atmosphere by rho g plus, look, here this is the surface, free surface, and as fluid goes on, the level or the velocity at which this level decreases will be very small, correct? Even though some fluid is coming with some high velocity here, but of course the speed or the velocity at which this level starts coming down will be very less. So we can assume this, if you call these points as 1 and 2, v1 square by 2g, and we can assume this v1 to be very small. So this is 0 anyhow, plus z1 which is nothing but this height h, which is h. This should be equal to, at this point if you apply, again this is getting open to the atmosphere, so definitely the pressure that's acting at this point will be the atmospheric pressure. So P atm by rho g plus v2 square by 2g plus z2 plus losses HL, what we have, correct? So anyhow, if you take this as the reference, then this z2 is 0. If you take this z2 as the reference, means basically this pipe axis is the reference, then z2 is 0. P atm by rho g gets cancelled, and HL, and of course this is coming, so velocity is given, h is equal to P atm by rho g plus v2 square by 2g plus losses, which is HL, correct? This is what we can write here. So now h is given, this is equal to v2 square by 2g plus HL, and HL is nothing but hydraulic losses or the head loss due to the friction. So definitely FL V square divided by 2GD. This is what we can have here. Okay, so anyhow, water level in the reservoir is 10. The pipe diameter is 20 centimeters. So here we have a pipe diameter of 20 centimeters. So Q dot is equal to, or discharge is equal to 0.1 meter per, this is meter cube per second. So this is meter cube per second. Okay, so and so we have the area. So A is equal to pi by 4 d square. Pi by 4 d square. See, diameter is 20 centimeters. So 20 is nothing but 0.2 meters. So 0.2 whole square. Pi by 4 d square. So we can cancel this. This is 0.04. So 0.01. So area is equal to 0.01 pi. So if you want the velocity at the exit, 0.1 divided by area, which is 0.01 pi, which is 10 by pi. Okay, so 10 by pi meters per second is what your exit velocity. So let us substitute the things. H is equal to V2 square by 2G plus FL V square by 2GD. Okay, this is what we have. So H is equal to, which is H is 10 meters. So let us write 10 meters. This is equal to V2 square by 2G. V2 just now we calculated. This is V2 is 10 by pi meters per second. So let us square this. So if you square this, 100 by 20 pi square plus F. That's the friction factor is given. Please give me a minute. I think I clicked on extra page here. Yeah. So let us delete this. Fine. So see here. F friction dash is friction factor is given, which is 0.02. So 0.02 L V square. The velocity, average velocity is 10 by pi square, which is 100 by pi square by 2. Okay, let us write a bit clearly. So 2G, and diameter of the pipe through which is flowing is 20 centimeters. So 20 into 10 power minus 2. So you can calculate what's the length L from this equation. So let us try to calculate. This is 5 anyhow. So 10 minus pi by pi square divided by minus. Okay, 10 minus 5 by pi square. So let us perform few calculations here. This 2 into 10 power minus 2 cancels this 0.02, and this 100 cancels these two things. So L by 2 pi square is what you have. So this has to be multiplied with 2 pi square. Okay, so 20 pi square minus 10. L is equal to 20 pi square minus 10. This is what we have. So let us quickly calculate this value. What is this value? L is equal to 20 pi square minus 10. It's a simple thing. It's just mathematical calculations, but of course, this is the fundamental equation, that the Bernoulli's equation that governs this, complete situation here. Normally, whatever the head is there, that should be equal to the energy at this point plus the losses. So definitely, this is what we have. So we know 20 pi square minus 10 is the value. So now let us calculate this. 20 pi square. Okay, 20 pi square minus 10, which is 187.39. So which is 187.4 if you round off to one decimal place. 187.4 to one decimal place. Okay, then this is not 197. I'm sorry, this is 187. Okay, so 187.4 is the correct answer. Right. Just a second, guys. Yeah, okay, fine. 187.4 meters. Normally, if you round off to one decimal place. Okay, so 187.4 is the correct answer. Did any of you get 187.4? Did any of you get 187.4? So please respond, because I hope calculations are correct at every point. Correct? Yes, sir. I did 187.4. Correct, Animesh. It's 187.4. Yes. I hope you guys are enjoying this session of fluid mechanics. Correct? You're knowing the answers, and also you're knowing the approach how to solve the things. Okay. Fine. So 20 pi square minus 10, basically 187.4 something is coming. Okay. Fine. Let us go ahead for next question. Something is given. Which of the following options is true? Okay. Path lines and streak lines are the same in any unsteady flow, and streamline and streak lines are the same in steady flow. But of course, even in unsteady flow, they need not be same, because path lines and streak lines, they are two different concepts actually. So definitely these two need not be same. But of course, as you know, the streamlines are the tangential to the local velocity fluid, because you know, if there is any velocity field, then if you want to have a streamline, then definitely the streamline will be parallel to the local velocity vector direction. So definitely this question is correct. This statement is correct, and also streamlines and streak lines are the same in a steady flow. And of course, in any steady flow, you know, streamlines, streak lines, and path lines, all these will be same. So definitely this is the correct answer. Right? Okay, this is the correct answer. Okay, because this is the concept of streamline. If there is any flow field, then definitely, if this is the local velocity vector, then your streamline will be parallel to this, or tangential to this velocity, tangential to this flow field at any given instant. Okay, shall we go for the next question? Okay, something is given. Which one of the following statements is true about the continuity equation dou u by dou x plus dou v by dou y plus dou w by dou z is equal to 0, where u, v, w are the velocity components along the x, y and z coordinates respectively? The equation is valid for both steady and unsteady incompressible flows. Look, I'll tell you one thing. If you write the continuity equation, then you know the continuity equation is something like dou by dou t plus divergence of rho v bar is equal to 0. This is the continuity equation in vector form, of course. So now if you write it in components, look, see carefully, dou rho by dou t plus divergence of this, which is nothing but dou by dou x of rho u plus dou by dou y of rho v plus dou by dou w or dou by dou z of rho w is equal to 0. Of course, here u v w, I mean in the velocity vector v bar, you have u I plus v j bar plus z k bar. Sorry, w k bar in the z direction. So this is the velocity vector. So if this is any velocity vector, then definitely this is the continuity equation in the vector form. In the differential form. And of course, this continuity equation, if you expand a bit, this is how you write the components here. Now, one thing has to be done carefully. If this equation has to get converted in this form, which is here, if this equation which is here has to get converted into this form, look. So I felt this year paper was a bit tricky. Of course, when it's IIT Bombay, you can expect that trickiness. Okay, cool. Because a few professors for fluid mechanics may go from IIT Bombay as well. Look, there is one common misconception in students' mind that if IIT Bombay is organizing GATE 2021, then the complete question paper will be set by IIT Bombay. No, it doesn't happen. I am telling you frankly. Because question paper will be set by faculty team from all the IITs. Okay, what they mean by organizing institute? They'll create a website, they'll open the application forms, they'll conduct examination, they'll announce the results and all. But for setting the question paper, you will be having the faculty team from all the IITs. Okay, so it's not like 2022 is being organized by Kharagpur, so all the questions will come from Kharagpur faculty. No, it doesn't happen. Okay, but there is some chance that, let us suppose if IIT Kharagpur is very much strong for design, then for framing few design questions, they may send the faculty corresponding to design module. Okay, this can happen, but it's not like completely all the 65 questions will come from a particular IIT. This never happens. Okay, so please don't think of that. Anyhow, let's get back to this. So if this equation has to come into this form, look, I'll tell you. Once the flow is incompressible, look, if you assume only steadiness, then this only term will go to 0. If steadiness is the only thing, then this rho need not be a constant. Clear? Because even in steady flow, there can be a chance that rho, look, if this is a pipeline, then it need not be, if this is rho inlet and if this is rho outlet, then it need not be same. Correct? Of course, if this is 3 kg per meter cube and if this is 4 kg per meter cube, then still this is a steady flow, because this 3 doesn't change with time and this 4 also doesn't change with time. But once the fluid is incompressible, means if the density is remaining constant, only then this dou rho by dou t will be 0 and you can take density out of all the differentiations. Okay, so look, for taking this density out of the all differentiations, you need to have rho as constant. It doesn't depend with time. Okay, it's basically the nature of the fluid, which is the fluid has to be incompressible. Clear? Only in case of incompressible flows you can take out this rho constant, but not in case of steady times, because I'll tell you, you can see the situation. This is a situation of steadiness, but it's not of incompressibleness. Clear? So definitely, oh, I'm sorry. Yeah. Where are things? Okay. Anyhow, so anyhow, this equation is of our main interest. So definitely, if you have to take this O out, definitely this O has to be incompressible. And once if the flow is incompressible, then it doesn't matter whether it's steady or unsteady, because rho remains constant. Rho remains constant in this case. Okay, so as long as this rho remains constant, all these terms like dou rho by dou t will be 0, because not because of this steadiness, but because of this incompressibleness of the fluid. Okay, plus density times, you can take the density out, so dou u by dou x plus dou v by dou y plus dou w by dou z. This becomes 0 in this case. Okay, and if this is 0, then you can cancel density because the other side is 0 anyhow. So this equation actually, which is the differential form, dou by dou t plus divergence of del v bar, if this is equal to 0, then definitely this continuity equation gets reduced to this form. And of course, this happens because of the incompressibleness nature of the fluid, but not because of the steadiness effects. Okay, so once the flow is incompressible, then it doesn't matter whether it is steady or unsteady, your continuity equation always takes this form. Is that clear? So please make a note of this point, because I think many of you might have answered this question as valid only for steady incompressible flows. No, even if the flow is unsteady, but because of the incompressibleness of nature of the fluid, this term gets 0. Okay, and this is the only term which is having some time involvement, so that will be 0. Okay, clear? Did you all understand this? Why during the incompressible flows for both steady and unsteady, this is the continuity equation? If you guys understand that much, I'll be more happy for that. Clear? And of course, if you're liking the session, please do like the videos, because you know, it's a known fact, if you increase the likes, the reach gets increased and many others could get benefited out of this. Okay, and since we are giving this for free, there is nothing, you know, it harms any others. Fine, let us go for the next question. Oh, I think this is, where is the next question? Yeah, this is the next question. So see here, in a laminar incompressible flow, fully developed flow, okay, this flow is also fully developed. So the flow is fully developed flow, laminar, and it's a circular pipe of radius r anyhow. Okay, of a Newtonian fluid as shown in the figure. So u is equal to u into 1 minus r square by r square, and you know, generally this capital U is a u max, because we know generally for this Hagen-Poiseuille flow, which is the laminar fully developed flow through the pipe, then definitely u is equal to u max into 1 minus r square by r square. Okay, so this is what you have. So when will Soman and Damo come? Maybe tomorrow, because it's already 1 o'clock, I mean 12:35 already, so we can't extend this Tom and strength of materials and Damo, but tomorrow we'll be having definitely the thermal key, so I'll just announce the key. Okay, and if you want, we can even provide detailed solutions as well, that's not an issue. Fine, anyhow, so let's take out the things. So this is what you have. The pipeline is of length L and the fluid viscosity is mu. The power P required to sustain the flow is expressed as P is equal to C times mu L U square. Okay, so this is what they have given you, and they are asking you where C is a dimensionless constant. Okay, some C, this C is a dimensionless constant, so they are asking you what's the value of this constant C. Okay, so they are asking you for what is the value of this constant C, and you know, power required to maintain the flow is nothing but rho G Q HF. This is what the power required for maintaining any flow through the pipe, and of course this is the fully developed flow, so definitely, you know, you can write this P is equal to rho G Q. Discharge is nothing but mean velocity into area of cross section. So if this is you know, complete pipe, then discharge is given by pi r square, or which you can write as pi d square by 4 into V average. You know, if this is U maximum, then you know, in a plane Hagen-Poiseuille flow, then definitely this average velocity or V average is nothing but V max divided by 2. Correct? And of course, you know, V max is at the center line whenever this radius r is equal to 0. So whenever this radius r is 0, your velocity is just a maximum at this point, and then definitely, so please provide it for aptitude. Okay, we'll try, because you know, today in the afternoon around 3 p.m. is what we got the response sheet, so we are trying out the solutions still, and definitely we'll provide. Okay, no issues. And of course, please hit the like button and please try to increase the likes of the video so that the reach gets increased and even many others could get benefited out of this. And of course, if you are on this channel for the first time, please do subscribe to the channel, because I'm telling you, very soon we are going to launch a comprehensive fluid mechanics course which is absolutely free. Okay, so from 1st of March we are planning on this channel. So daily on this channel we'll take a class of 1.5 hours for fluid mechanics exclusively, and you can get a lot of other content which is for free on this channel. Already on this channel, as I told in the beginning of this lecture, you can find the course of engineering mathematics and also basic thermodynamics, which are done by me, and of course you can find them for free. Okay, so anyhow, let's get back to the thing. So here we average, which is u max by 2, so this is u by 2 into hf. Now what about hf? 32 mu v L by rho g d square we can write. So 32 mu, again v is nothing but average velocity, so u by 2 L by rho g d square. This is what we can write. So let us cancel the simple common terms and all in the numerators and denominators. Rho g gets cancelled. This d square gets cancelled, and still we have few things to cancel here. Yeah, we got this 4 which gets cancelled 8 times, and this 2 cancels this 4 times, and of course this 2 cancels this 1 more 2 times. So what we have finally, your P is equal to pi u 2 mu u L. This is what we have. Okay, so which means we can write 2 pi times mu u square L or L u square. This is what you can write here. Okay, so this is the constant that's given. So C value is 2 times of pi, which is 6.28. That's it. Clear? It's a simple analysis, just cancelling out common terms. But the only thing that you need to remember, whenever you are trying to write discharge, area of perpendicular flow means basically the area perpendicular to the direction of flow into the average velocity is what you need to write. But here this u is the maximum velocity, because clearly this is the condition of a plane Huygens-Poiseuille flow, which is the completely developed laminar flow inside a pipe. So definitely whenever you are trying to attempt this v, this is nothing but u by 2, half of this u max. Okay, so this is the only point that you need to keep in mind, and if you know that, then just cancellations and all will give you 2 times of pi into mu L u square, and 2 pi value is 6.28 basically. Clear? Is that clear to all of you? Okay, this is a very much easy question. Hf is nothing but 32 mu v L by rho g d square. So if you cancel out all the things, you will get 2 pi into you can see clearly 2 times of pi into mu into u square into L. Okay, so the value of this constant C is 6.28. So since they asked you to round off to 1 decimal, you can approximate this to 6.3. Clear? Look, for every answers which are not exact, like few calculations they give you exact values like 1.5, 2.4, things like that. But of course, for every question that's involving some decimals, means where answers need not be exact, IIT definitely considers all the approximations that can be taken, and it gives a suitable range so that no student will be losing marks unnecessarily. Okay, because they all know the importance of gate, so they don't generally put you in trouble. Okay, clear? So let's go for the next question quickly. We have 7 more questions left. So after solving these 7 questions, we'll go for some other. We'll end up this session basically. So the form and friction drags together contribute to the total drag. Of course, it's quite common. So total drag, let us write total drag is equal to skin drag, or generally it's foam drag, plus drag due to pressure difference, which is the basically which we call this as total drag is because of foam drag and friction drag. Okay, so friction drag we'll call this. So now one thing you can see clearly here. In this case, one thing that you can observe, the skin friction will be very less, correct? Because things are like this. So here, if you consider the form friction, then definitely this has a higher form friction compared to the, this has a higher form friction compared to the friction drag, because more area is getting exposed. So if you go to the options, let us see the options. In the options, we have orientation 1 has higher form drag. It's obvious because much of the area is perpendicular to the flow, and of course, in this case, the lower friction drag means like the friction drag in this case is almost negligible, because the component is completely perpendicular to the direction of flow. But here in this case, it's something reverse of this. So definitely you'll be having higher skin friction in this case. So definitely friction drag will be higher, and of course foam drag will be lower in the second orientation. It's quite obvious whenever the flow is in this direction, and if you are having a film solid structure here, then definitely you will experience a lot of foam drag, and that's common intuition for any one of us generally. And this foam drag is generally high in this case. Okay, and of course here not much of the area is just this is 90 degrees rotation of this plate, correct? So in this orientation, majority of the air passes in this way, but very few portion of the air gets interacted with this surface. But of course here in this case, you can see there is a lot of surface area that's exposed to the air coming out, so the form drag will be very much high in this case. Okay, so orientation matters a lot, and this actually plays a very important role when creating lift forces and all in aerodynamics. Okay, Next, so anyhow, C is the correct answer for this. This has a higher form dog and of course higher friction drag in the second case. Next, let us go to the things. A of density 0.5 kg per meter cube enters horizontally into a jet engine. Okay, so many times you may see airplanes flying, correct? The airplanes have something like this to fly with a engines here. They have their engines located here. Have you seen? There will be some aerodynamic wings and of course there will be some engines here. So let us talk about this engine in a big scale. Let us talk about this engine in a big scale now. So there is one jet engine. So let me try to attempt one jet engine. Let us draw the control volume with a different color so you can appreciate much. Let me try to draw a jet engine. I am a very bad artist, so please consider my drawings for this time. So there is one jet engine. Okay, there is one jet engine that's coming. No, I don't discuss solid mechanics now because it's already late night and I expect you should have some decent sleep. So not right now, but maybe tomorrow. So see here. So this is one jet engine basically, and A of density 0.5 kg per meter cube is going in. So whatever the A that's moving in, that has a density of 0.5 kg per meter cube. Okay. Next, enters horizontally into the engine. So the direction of flow is horizontal. At a steady speed of 200 meters per second. So V1, the velocity at which this is flowing is 200 meters per second, and of course to an inlet area of 1 meter square. So this area of cross section through which this velocity is going, through which this A is going is 1 meter square. Next, upon entering the engine, the air passes through the combustion chamber. So basically you have a combustion chamber inside the engine, that's obvious, and the exhaust gas exits the jet engine horizontally at a constant speed of 700 meters per second. It's quite obvious. Generally for the jets, the exhaust velocities will be more, so definitely this V exit that they are maintaining here is how much? 700 meters per second. The fuel mass flow rate added into the combustion chamber is negligible. So normally the engine sucks the air and of course you will be having some fuel injectors so that they inject the fuel. But of course compared to the mass of air that the jet engine is taking in, the mass of the fuel is neglected. Okay, that's fine. Also neglect the pressure difference between the inlet and the exhaust gas. So basically here whatever the pressure you have, the same pressure you have here, and this is also equal to the P inlet. Then the absolute value of the horizontal force in kilonewtons. So normally you can see there is only velocities and areas that are involved. So we can straight away apply this momentum balance, correct? So if you want to have this momentum balance, this Fx is equal to mass flow rate or the final momentum minus initial momentum. So m dot out V out minus m dot in V in. But of course you can see the mass of the fuel that's being injected is neglected. So whatever the mass of air or the mass flow rate of air that's going in, same should come out, because all the engineering devices, majority of the engineering devices, they occur or they operate under steady states. Okay, what happens if they don't operate under steady states? I'll tell you. Look, because since we have some time, let us talk. Normally you will assume steady flow energy equations at any points, and you will assume equations or the equipments are running at steady state. What happens if the equipments don't run at steady state? Look, at the end your equipment will have some finite volume and some temperature limits and all, correct, for the materials. Now let us suppose if your mass flow rate inlet is 2 kg per second and if it's going out at 3 kg per second, then after some finite number of cycles you get a situation that your volume inside or the substance inside the tank gets done. Or else, if let us suppose here if it's coming 3 kgs and if it's going only 2 kgs, then what happens? After some time your complete volume gets filled with the fluid. Yes or no? So definitely in engineering operations like boilers, turbines, or compressors, jet engines, everywhere, it is most preferable that they should run at steady state conditions. Okay, so this is one very important thing. And of course this is one such case. So anyhow, mass flow rate that is going in is equal to mass flow rate that's coming out. So Fx is equal to, what is the mass flow rate? See, both are equal. M dot out is equal to m dot in, and this is also equal to m dot. Okay? This is what we have. So m dot is nothing but rho a v, because mass flow rate in kg per second is nothing but density into area into velocity. So density is 0.5, which we write it as 1/2. Area is 1, velocity is 200 into V out minus V in. You know, V exit is 700 meters per second and V inlet is 200 meters per second. So 700 minus 200, since both are oriented towards the positive direction of x-axis, we write 700 minus 200. Okay, so now this gets cancelled. 100 into 500. So 100 into 500, we can write it as 50 kilonewtons as the total horizontal force that's acting on this combustion chamber. Okay, so this combustion chamber forces are really important because, you know, these engines are fitted to the wings of the airplane. Okay, so depending on these horizontal forces, how much thrust they are experiencing, the designs have to be done clearly. Okay, if you move into a bit of aerodynamics, this plays a very important role. But of course, right now, find the horizontal force is what they asked us, and the net horizontal force on the jet engine is 50 kilonewtons, which you could easily see from just a momentum balance, and of course this is 50 kilonewtons. Clear? Okay, so is that fine? Shall we go for the next question? 17 questions are already done, so we have 5 more questions. That's it. Come on, let's enjoy last 5 questions. Okay, fine. Consider the fully developed flow of a Newtonian fluid of density rho, viscosity mu through a smooth pipe of diameter d and length L. So basically, there is one smooth pipe of diameter d and this length L. Then they are asking you for the this is a fully developed flow of a Newtonian fluid. The average velocity of the flow is v if the length of the pipe is doubled, keeping v d mu rho constant. The friction factor, look, one very important thing, the friction factor is nothing but some constant, or you can write the friction factor f is generally a function of some function of Reynolds number alone. You know this, correct? Your dash is friction factor. Friction factor depends only on Reynolds number. Of course, this is 64 by Reynolds number in this case. You know, friction factor is equal to fully developed laminar flow through pipes. Of course, laminar flows, this is 64 by Reynolds number, and of course, in generally, any friction factor is only a function of Reynolds number. Now, one thing is very clear, your Reynolds number is nothing but rho V average characteristic length. Of course, in case of pipe, it's diameter divided by mu, correct? And it's clearly given V. Okay, if the length of the pipe is doubled, keeping V constant, which means this V average remains constant, D constant, which means this D is constant, rho is constant, so rho is constant, mu is constant, and mu is also constant, which means one thing, the length doesn't impact the Reynolds number, which means your Reynolds number is not changing. And whenever this friction factor is just a function of Reynolds number, and if this Reynolds number is not changing, then definitely this friction factor doesn't change. Clear? This is the only reason for this, and you know, this f is only a function of Reynolds number. Please try to remember this, and of course, this is the value in case of fully developed laminar flow through pipes for the friction factors. Okay, and so this Reynolds number doesn't change basically because all these 4 terms are constant. So basically, your friction factor doesn't change, but your head losses will change because you know head loss is nothing but FL V square by 2GD. So this will change because your length is changing, but normally friction factor doesn't change because of changing of your length. Clear? Is that clear? So this remains the same almost, no changes, because this depends only on Reynolds number, and Reynolds number depends only and only on these 4 quantities: velocity, diameter, density, and dynamic viscosity. Clear? So that's how this is same. Is that clear to all of you? So shall we go for next question? We have 4 more questions. So shall we go for the next question? Okay, this is one good question. A spherical metal ball of density ρs. So this has a density ρs and attached to a string is exposed to a cross flow of velocity u infinity. So you can see clearly there is a ball that is suspended and there is some cross flow of a onto this. Okay, due to the cross flow, the string makes an angle of inclination theta. It's obvious because if some fluid is flowing, this fluid exerts a force on this ball and it tries to push the ball from its equilibrium position like this, correct? With the top surface as shown in the figure. Okay, this string is making an angle theta with the top surface as shown in the figure. Fine. The acceleration due to gravity is denoted by g. Okay, you can see gravity always acts downwards. For this flow, Reynolds number is very much less than 1. So it's a quite laminar flow, and of course the Reynolds number is very small because you know the medium is many times it's quiescent. Okay, so for such cases, so generally this u infinity will be very small in general. And buoyancy forces in the fluid is negligible, of course, because when this bob is completely surrounded by the fluid, it's quite common that the bob experiences some buoyancy force from the fluid, but of course it's given the buoyancy forces are negligible. Okay, compared to the viscous forces. So viscous forces are of considerance, but buoyancy forces are neglected. Assuming the string to be weightless and offering negligible drag, the expression for theta. Okay, so they are asking you for the expression of theta. Let us try to reconstruct the structure. So basically there is some string and some bob is hanging on here, and there is some free flow on this. Okay, so this is moving at u infinity and u infinity rho f mu. Okay, so this density is rho f and this is mu, and the density of this material is rho solid and this diameter of the bob is d. Now please tell me one thing, this is in equilibrium. One thing is very clear, because of the viscous forces that acted upon this bob by this fluid, this is in equilibrium under this angle theta. And this is what you have, correct? So if this is the case, now see carefully. If you try to write the equilibrium of the bob, because the bob or the ball here, let us call ball or bob, if a pendulum it's called bob generally. So if this bob is in equilibrium, then let us identify few things. This viscous force on the bob acts in the horizontal direction, undoubtedly. This is F viscous. Let us write FV, that's it. Okay. Weight of the bob acts this way and tension in the string acts this way. And of course, if you see, if this angle is theta, then this angle will also be theta. So this angle is theta, undoubtedly. Now, if you resolve this t into components, we have t cos theta and here we have t sin theta. Correct? So this is what we have. So let us write this t in a dotted line because we have already resolved the components. Okay, so let us maintain some dotted line for t because we have already resolved that. We need not consider this again. So this is theta. Now, since the bob is in equilibrium, we can write one thing, sigma f vertical is equal to 0, which means t sin theta is equal to weight of the bob, which is mg. And if you apply sigma fh is also is equal to 0, because when it's in equilibrium, all the net force has to be 0. So this implies t cos theta is equal to viscous forces, F viscous. So if you divide these two, we have Tt gets cancelled and tan theta is equal to mass of the bob. Mass of the bob is nothing but density into ball is of sphere generally, and you know what is the volume of the sphere? Pi by 6 d cube. So pi by 6 d cube into gravity. This is what's the mass of or the weight of the complete bob divided by now F viscous. You know Stokes law of viscosity. So if there is some fluid within the path of any, if there is some body within the path of this fluid, then the force, viscous force, is equal to 6 pi mu v d or r. You know, generally you can write r, 6 pi mu v d, 6 pi eta v r is what they write generally. So which we can have here. I'm sorry, this is d. Yes, they write the diameters. Sorry. Yeah. So 6 pi mu v d. This is the Stokes law of viscosity, which you might be studying in your class 11 or something like that in your basic fluid mechanics course. So Stokes law, 6 pi mu v d. So now this implies, or let us write this here, 6 pi mu v d. This is what we can have here. So this cancels this d square times, and tan theta is equal to, look, g is 10 anyhow. Okay, g is 10, it's given. Let us check the data from the question. So g, okay, it's not given. They have mentioned g in the options. That's fine. Okay, so this is what we have. So density of solid into pi into, okay, pi gets cancelled anyhow. So let us not take care of this pi anymore. So pi gets cancelled. D square g by this 6 comes here. So 36 into mu into v. So this is what we have, of course. So if you perform this calculation a bit carefully, or else, guys, please make a note. This is radius. Yeah. This is radius. So here we have a radius. Okay. Into radius. So this is acceleration due to gravity. So let us retain this as d cube, and by 36 into mu v into r. R is nothing but d by 2 now. So this we can write. So d cancels this d cube d square times, and 2 cancels this 18 times. So finally we have this tan theta as, look, 1 by 18 rho solid d square g divided by mu v. This is what we have, and this is given in one of the options actually, mu v into this thing. So let us see 1 by 18 into d square OSG by mu u infinity. Okay, and here because v is generally given by u infinity here, so this is the velocity of the flow. So we are using v, but in the question it was given u infinity. So it's just a denotation anyhow. So tan theta is equal to 1 by 18 times of density of the solid into d square g divided by mu into v. Of course, if you want to replace, you can replace all these v's with u infinity because it's just a matter of denoting. So this is u infinity anyhow. Okay, this you can write this as u infinity if needed. Similarly here. Okay, so finally we have this tan theta is equal to, so this expression, I mean theta is equal to, okay, because tan theta is equal to 1 by 18 d square rho solid g by mu into u infinity, which we got here by this particular analysis. So definitely we can have 1 by 18 into this particular term for theta, which is of course a tan inverse. Clear? So vent losses, of course. So 20th question, the head loss associated with the flow entry of water to an internal passage depends on the shape of the entry. The following figure shows 3 different types of flow entry into a pipe. So basically here you have a straight entry. Let me use different color. So here you have a straight entry, but of course here you have an obstruction well before, and of course here you have a smooth cool bend. Now one thing is very clear, whenever these bends are smooth, the friction losses or the head losses will be very less. This is one thing. So compared to these two cases, the head losses in this case should be very less because they have smooth edges for the fluid that they send in. Okay, so since the edges are smooth, definitely the head losses will be less, which means head losses in case of C has to be minimum. Similarly, whenever you have these bends well advanced, fluid energy already starts distracting at this point because of these hurdles, and still during the flow it still loses its energy, okay, because there is well advanced hurdle before this. So out of all these 3 things, your head losses due to bends will be high in case of B, and you can clearly see from your intuition that this losses involved in this case will be a bit less than this because the projections are not very much out, and normally it's the order of KLB greater than KLA greater than KLC. Okay, and generally the head loss coefficients were given. In this case it will be 1, in this case it will be 0.5 to 1 around, and of course in this case very less, like 0.01 and all. Okay, head loss coefficients generally for minor losses we multiply with the correction factors directly. So in case of those correction factors directly, we'll put 1.5 and 0.01, which you can find in many standard books, even SK SOM and all. But of course by intuition we can tell, we may not tell the values, but we can tell this is the correct answer because you can experience that losses in this situation will be a bit more comparatively. Okay. Next, let's go for the last 2 questions. Okay, this is one question that we have again. So water of density 10 cube kg per meter cube, so 1000 kg per meter cube, enters steadily into a horizontal pipe bend. So there is a horizontal pipe bend through which this is going, which is a part of a larger piping system as shown in the figure. The volumetric flow rate of water is 0.1 meter cube per second. So if you write the solution, the volumetric flow rate is equal to 0.1 meter cube per second. The gauge pressure at the inlet is 500 kilopascals. So at this point or at this section, the gauge pressure at the inlet. So at this inlet, we have this gauge pressure is equal to 500 kilopascals. Okay, and the area at the inlet is also given. Yeah, it should be given. So area at inlet is equal to 200 centimeter square. Okay, this is given, which 200 centimeter square you can write it as 200 into 10 power minus 4 meter square. So which is 0.02 meter square. This is what we can have. That is fine. So while the exit is open to atmosphere, so this is an exit which is open to atmosphere, PATM. Okay, the x component of the force on the support is Fx. So on this support, the x component, net x component of the force is Fx because x is given in this direction. Okay, so this net component is Fx. Fine. Then the absolute value of Fx in kilonewton. So it's very easy question actually. There is some mass flow rate of the fluid that's entering into this pipe, which is of this bending shape, and the inlet area is 200 centimeters square, and the pressure exerted is of course in the left direction and it's in the right direction. So no issues. Let us apply this momentum balance. So sigma Fx is equal to 0. So which implies, look, Fx, which is the force with which you need to hold this support. Otherwise, because of this motions and all, the support gets distracted. So definitely we need to hold the support with some force Fx minus. So initially there is some force due to this pressure which is going left side. So let us, since both are, this is also exposed to atmosphere, let us consider only gauge pressures here and we'll neglect the effect of this pressure at the outlet. Okay, so P gauge into inlet area. So minus P gauge, which is 500 kilopascals, into area, which is 2 into 10 power minus 2. This should be equal to, of course, there is some mass fluid that's going in. So we can have rho AV square. So rho area is again 2 into 10 power minus 2. And this density is 10 cube. So let us write 10 cube straight away. So 10 cube we can write rho A V square. What is the velocity at which it is going? So discharge is given. Okay, so discharge is given. So Q by A inlet 0.1 divided by A inlet is 2 into 10 power minus 2. So we can cancel the 10 and this is 5 meters per second. So 5, which gives you 25 because rho A V square plus then the velocity. Okay, then here it's coming in the positive direction. Of course, the velocity is 100, area is 100 centimeters square. So velocity V2 is equal to 0.1 divided by 100 centimeters square. 100 centimeters square is nothing but 100 into 10 power minus 4. So this gets cancelled and V2 is equal to 10. So we have 10 here. So sorry, this is 10. So 10 cube into area is 100 centimeters square. 100 centimeters square is 10 power minus 2 into V square, which is 10 square. So this is what you have finally. And if you perform this calculation, you will get Fx is equal to 11.5 kilonewtons. It's just awaiting all the forces. See, many times I'll tell you one thing. Look, I'll tell you one thing. Many times if you have that doubt like whether to write which terms on right hand side or left hand side, you do one thing. You put an equal to sign. You put all the terms in one direction here and you put all the other terms in another direction here. You'll end up with correct answers finally. Okay. So this is one technique that we generally use. We can put all the terms that are in one direction on one side of the equation and all the other terms which are in the other side of the equation, which are in the other direction basically. So you can use this technique for evaluating the answers, and of course this calculation, if you do correctly, it will give you 11.2 kilonewtons. Okay. If you want, you can digest. So this is 50 and this gets cancelled 10 power minus 2 and this, so it will be 10 kilonewtons, that is 1, and this is 0.5. So totally you will be getting 11.5 kilonewtons. Okay. Fine. So shall we go for the last question of the fluid mechanics then? 21 questions are done already. 21 questions are done. So please tell me, shall we go for the last question? Yes or no? So please tell me, shall we go for the last question of fluid mechanics? Okay, then here is the last question. So let us see this. The incompressible flow of air over a... So provide paper of this with answer keys. Yeah, definitely I'll provide. So if you are on this channel for the first time, please do subscribe the channel because we are going to put a lot of important content or useful content to many of the engineers. So please do subscribe the channel. And of course, if you are liking the sessions, please do like the videos and our effort. And also in the description box, we will be providing the links for all the ways that you can contact Engineers Hub. Okay. So I wish you all a very good luck. Anyhow, let's get back here. This is the last question that we have. The incompressible flow of air over a curved surface having possible flow separation is schematically shown in the figure. So one thing is very clear. There is a schematic flow that's shown here. So there is some curved surface like this and there is some flow on the top of this. Okay, let us draw the flow lines with a different color. So these are the flow lines. Okay. So two zones P and Q are indicated in the figure. So at the midpoint of the body, so left of this there is zone P and to the right of this there is zone Q. Then which of the following combinations is true for zones P and Q? Okay. So see here. This question is a nice question. Because this is the point and they are asking you if this is your zone P and if this is your zone Q, then what are the things happening? Now, you know, whenever you have an obstacle, the boundary layer starts developing till this point. And at this point, there is a possibility that if your velocity gradient is getting positive, then your flow may not separate. But of course, if your velocity gradient starts getting negative, then the flow may get separated. This is one thing that we have. So basically, whenever you can see one thing clearly, also, as your flow goes on like this, your area of the flow starts decreasing. Means basically the fluid achieves convective acceleration and generally this pressure gradient in this locality will be less than 0, which is favoring for the flow to happen. Okay, and to the right of this we have an adverse pressure gradient generally, because the fluid actually starts decelerating once it crosses the maximum point, and that's called the flow separation point, because the flow may get separated from this plate or from this body actually. So this is what we can have. I solved only 10 questions in mathematics. Okay, I think one question is missing. Yeah, many of you are talking about that, so no issues. Okay, answer will come in 12 question. It's 197.4, but I think we applied the Bernoulli equation correctly at all the points, so I hope it could be 187.4. Okay, no issues. Anyhow, we'll check, but at the best of my knowledge, it's 187.4 because the Bernoulli equation is getting valid at all the points. Very fine. Okay, so anyhow, this is what we can have. So definitely in zone P, we have this favorable pressure gradient. You know, pressure gradients are generally negative whenever the flow is happening. So dou P by dou X is less than 0 in this case. So this is favorable for the flow to happen. So favorable pressure gradient is what we have here. And of course, you can see as your flow increases, the area of the flow is slightly decreasing. So which means the fluid achieves some acceleration as we are talking about. So definitely there will be acceleration in P, and there is some favorable pressure gradient. And also whenever there, 187 could be the correct answer. 187.4 could be the correct answer, because look, many times formulas don't work out, but always fundamentals will work out. So definitely you can have your fundamentals strong and apply the Bernoulli equation at different points. Okay, that could definitely help you out. Next, let us finish this question, because this is the last question in fluid mechanics that we have, and it's already 110 AM. Okay, fine, that's okay. So, and no flow separation, because obviously whenever there is some acceleration of the flow, and if the flow is getting to build, then definitely there won't be any velocities either. There won't be any flow separation. So definitely in this edge P, you can have, because of this negative pressure gradients, the flow won't get separated. But of course, at this point, there is a chance that the flow may get separated because of the maximum velocity that the the fluid may reach at that situation. Okay, so definitely for zone P, we have acceleration of fluid, no flow separation, and also favorable pressure gradient. So A, D, E should be there. So A, D is not there. A, D is not there here, and F is there. So this is the correct answer. Okay. So basically, you know this, during the boundary layer building, you will get, I would like to draw something for you if you would like to have some patience to listen. So normally here you see, in this localities, the boundary layer starts developing. Okay, you know this. You might have seen this diagram in many of the standard books also even. The boundary layer starts developing. But of course, this point at which the pressure is minimum, if you try to plot a pressure curve, this is the point at which the pressure will be reaching a minimum value. Okay, this is P minimum in this case, and exactly at this point the boundary layer achieves, or generally the flow achieves this condition, and the flow may start getting separated in this case. Okay, but of course for this, in math, many of you are complaining this. In math, you missed one rank question, but I was not able to recollect because the slide somehow it got missed, I think. Anyhow, we'll provide this PDF completely, then you can find that question. Okay, fine. Okay, so 22 plus 10, 32 questions I think we have solved in maths and this fluid mechanics. So I hope you guys have enjoyed the session. So because these are all the detailed solutions of fluid mechanics, and because it's already late, otherwise I would have continued thermodynamics as well. But anyhow, for thermodynamics we'll take tomorrow, and we'll finish the thermodynamics. And of course, if you're on this channel for the first time, please do subscribe the channel, because increasing the subscribers and likes will definitely increase the reach of the content, and that will get benefited to many others. Okay. And that rank question, sorry I don't have the data, but of course once I get the data, I'll definitely post the things, and you can find the solution of that in the PDF as well. Okay, no issues. Exceed D means you want me to cover this solid mechanics also. Okay, fine. Anyhow, we'll have some sessions tomorrow, so we'll try to have that definitely. I hope all of you are fine with the session. Are all of you okay with the session? Is that fine? Did you all get all the detailed solutions of fluid mechanics, and did you all understand how things are happening? That 187.4, I think 187.4 could be the correct answer, because Bernoulli equation is getting valid at all the times. Okay, forget about formulas and shortcuts here. Just trust your fundamentals and try to work out your fundamentals. Okay. Thank you, Naveen. Thank you, Srinivas Vibhute Chinav. Fine. Okay, then it's already 110, and you people in the anxiety of knowing the answers, you are awake till now. Anyhow, have a nice sleep. We'll meet tomorrow, today itself, after some 9-10 hours on the same channel. Okay. Thank you all. Have a nice time. Good night. Have a nice sleep. Bye. And I wish you a very good luck that you will be getting some good score in GATE 2021, and you will get your chances of life. Okay, thank you all. Have a nice time. Sleep well. Bye.